Welcome everybody. My name is Douglas Macedo and I'm from the Federal University of Santa Catarina in Brazil, and I'm the General Chair of the first EAI International Conference on Data and Information in Online Environments, that we affectionately call Dione. We would love to see all of you this year in Florianopolis to our conference. However, the safety and well-being of all participants is our priority. After studying and evaluating the announcements, guidance, and news released by relevant national and international departments, the EAI announced that Dione 2020 was changed to online edition. Dione is born as a response to the growing interaction between the information, communication, and computer science. And interdisciplinary space will be provided to enhance cooperation between data science, natural language processing, data engineering, big data, research evaluation, network science, sociology of science, and communication communities working on problems of fake news, social media metrics of science, online data processing, and related areas. The 2020 edition of Dione will consist of 2 keynote speeches and 6 technical sessions with 18 full papers. We highly appreciate the interest of all authors who trust Dione to submit their research results. We would like to give our special thanks to the organization committee, the members of the technical program committee, and the external reviewers for their willingness to collaborate. We sincerely appreciate the guidance provided by the European Alliance for Innovation and all support of the postgraduate program of Information Science of the Federal University of Santa Catarina. Last but not least, we would like to thank the speakers and attendees for being part of this conference. We hope you enjoy Dione 2020 online edition.
Dear ladies and gentlemen, please let me welcome you to EAI Dione 2020, the first EAI International Conference on Data and Information in Online Environments. It was originally scheduled to take place on 19th of March in Florianopolis, Brazil. But as you are all painfully aware of the global pandemic of coronavirus, it has affected all of us, and as well the conference had to be moved to this online virtual setting. All of this could not be done without tremendous help from the organizing committee and program committee, and the quick action by authors and speakers who made it possible by following our instructions and recording their presentations. Right from the beginning, I would like to thank you all for the excellent work that made this possible. Additionally, I would like to present a few ways to stay engaged with us on a couple of different levels. As you know, we are always on the lookout for potential conferences in various networks and communications fields, or the cooperation with our publications, where we are constantly working on better and better indexing for our journals and proceedings. There are truly many ways to collaborate with EAI, and we invite you to try this partnership, and please do not hesitate to reach out directly to me if you are interested. Importantly, I would also like to remind you not to forget about the opportunity to vote on presentations that will follow you. You will get to determine which presentation will be the best from this conference, and then afterwards the year's highest ranked speakers will get the status of distinguished speakers and will become eligible for keynote invitations for our conferences. The tool we have set up for this opportunity is called EAI Compass. Please find Dione conference there is where the voting takes place. Finally, this presentation was delivered by Barbara, the conference manager of Dione 2020. Some of you may remember me from our email exchanges. I hope you have a wonderful time during this event and that you will follow our next edition of Dione 2021 as well, which should take place in Florianopolis as originally planned on 10th to 12th of February in a traditional live setting. We will keep you posted and the news about this event will be posted on the conference website. After my presentation, my colleague, our community manager Michael, will share a few words about the EAI as an organizer of this event. Wish you all the best and enjoy. Thank you!
Hi everyone, my name is Michal Dudic and I am the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you and say a few words about who we are and what we can do for you and your research career. So in short, EAI is a global community for a greener, healthier and smarter world. As of today, we are a home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world, thanks to membership that is completely free. We organize more than 100 annual events, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, but what does it mean? And more importantly, what does it mean for you? So what we do is that we give our members, the EAI community, a platform that helps you build your research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. So firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper and your presentation. In addition to that, it lets you download all full papers that will be presented at this conference. You can vote on your favorite presentations, and you can see everyone who is here and connect with them. You can do this right now if you go to www.compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from various program committee members regarding the reliability and the speed of community review. So what does community review do? It is a website that shows abstracts of papers that are in the review process, as long as the authors allow it, of course. And all EAI members can then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, and these are sent to the program committee who decide whether or not this bidder is qualified. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process, benefiting you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all our conferences and journals that allows you to climb the global ranks of EAI community and get recognized thanks to your research. It calculates a number value for most actions you make, such as submitting a paper or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a membership rank, such as a senior member, a distinguished member, or fellow. For each action that is eligible for EAI index credits, we look at the quality of your action as it was evaluated by other members of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers and to junior engineers, every 12 months, every member starts at 0. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work in progress abstracts and get the kind of help you are looking for. Say, maybe you are looking for co-authors, maybe you would like to have a mentor, or maybe you want to find out how the research community feels about your idea. This is what Smart Submit is designed to help you with. Ultimately, this is about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged with EAI at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and to collaborate. So please, you can find out more about everything I've just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments or feedback at community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones were the best. And you can also use it to download all full papers that will be presented today. Just make sure that you log in using the same email as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Hello everyone. I hope everyone is safe and healthy during these challenging times. First, I would like to thank the General Chair Douglas Macedo for inviting me to give this keynote speech. The title of my presentation is Big Data Opportunities, Challenges, and Applications. My name is Miriam Capretz. I am a professor of software engineering in the Faculty of Engineering at Western University, which is located in London, Ontario, Canada. So this is the outline of my presentation. So I'll first introduce the topic, then I'll go over the challenges dealing with big data. So I'll then go over and focus on machine learning as one solution for big data analytics. Machine learning was originated at different times, so we need to find ways to adapt the existing machine learning algorithms to handle big data. So I will then proceed describing few machine learning paradigms that are suitable to analyze big data. So my research team has been developing projects with the industry for the past 8 years or so. So I will go over some of these projects and show how we have generated research and advanced the field in analyzing big data with real industry problems and real data. So I'll then conclude my presentation. So the big data revolution promises to transform how we live, work, and think by enabling process optimization, empowering insight discovery, and improving decision making. So the realization of this grand potential relies on the ability to extract value from such massive data through data analytics. The demand for knowledge extraction has been increasing. So with the growing amount of data that's been generated by global data sources like social media, mobile apps, and the popularization of context-specific data, such as the Internet of Things, so companies and researchers need to connect all these data and extract valuable information. Just to give an idea how much data we're talking about, in 2018, 500,000,000 tweets were sent out each day. So, like ABI research estimates that over 30 billion wireless connected devices to be part of the Internet of Everything this year. So these big data possess tremendous potential in terms of business value in a variety of fields like healthcare, biology, transportation, online advertising, energy management, financial services, and so on. So the amount of data generated has been continuously growing from global data sources like websites, social media, mobile applications, news networks, weather, political institutes, society, economy. So no matter how big the data are, they will be useless without proper preparation, processing, and analytics. With the popularization of sensors and mobile devices able to connect to a network, so the Internet of Things, it's becoming viable to collect more data from specific contexts at higher levels of detail. So by connecting global and context-specific data, it is possible to extract even more detailed information and build richer knowledge using machine learning algorithms. So, what we are talking here is that the realization of this grand potential relies on the ability to extract value from such massive data. And so machine learning is at its core because of its ability to learn from data and provide data-driven insights, decisions, and predictions. So let's look at Internet of Things and machine learning, for example. Gartner predicts that the Internet of Things will reach 26 billion Internet-connected devices this year, impacting a wide range of industries. So the IoT, what is IoT? It's about connecting any device to the Internet, enabling the digitization of devices, vehicles, and other elements of the real world. Machine learning has been increasingly used with IoT data to create new applications such as we have heard about smart cities, smart homes, and smart grids, and smart agriculture. So an IoT application may provide so vast amounts of real-time data through its applications and business layers. So analysis of this temporal data series through machine learning can provide numerous benefits in several processes and services. So we have been talking a lot about big data, how and where we are collecting them. So now I would like to go over some of the challenges that how do we handle this big data. So for example, traditional machine learning approaches, they were developed in a different era, and thus are based upon multiple assumptions like data set fitting entirely into memory, which unfortunately no longer holds true in this new context of big data. So these broken assumptions, together with the big data characteristics, are creating obstacles for the traditional techniques. So what are we calling big data? So the concept of big data is defined by Gardner as high volume, high velocity, and or high variety data that require new processing paradigms to enable insight discovery, improve decision making, and process optimization. According to this definition, so big data are not characterized by specific size metrics, but rather by the fact that traditional approaches are struggling to process them due to their size, velocity, and or variety. So the potential of big data is highlighted by their definition. However, realization of this potential depends on improving traditional approaches or developing new ones capable of handling such big data. So because of their potential, so big data has been referred to as a revolution that will transform how we live, work, and think. So the main purpose of this revolution is to make use of large amounts of data to enable what? Knowledge discovery and better decision making. So the ability to extract value from big data depends on data analytics, which can be considered then the core of this big data revolution. So let's talk about machine learning and try to understand a little bit more about machine learning. So according to the nature of available data, the two main categories of learning tasks, supervised learning and unsupervised learning. So supervised learning is when both inputs and their desired outputs, labels, are known and the system learns to map inputs to outputs. On the other side, unsupervised learning is the category when desired outputs are not known and the system itself discovers a structure with the outputs take discrete values, class labels, while in the regression, the outputs are continuous. So examples of classification algorithms are the k-nearest neighbor, logistic regression, and support vector machine. And examples of regression examples include support vector regression, linear regression, and polynomial regression. Some algorithms, such as neural networks, can be used for both classification and regression. Now, unsupervised learning includes like clustering, which groups objects based on established similarity criteria. K-means is an example of such algorithm. Predictive analysis relies on machine learning to develop models built using past data in an attempt to predict the future. So numerous algorithms include the support vector regression neural networks can be used for this purpose. So the labels in supervised learning can be discrete or continuous, which are handled by classification or regression. Classification is used most for prediction, pattern recognition, and outlier detection. And regression is using, for example, for prediction and ranking. Unsupervised learning is known as density estimation in statistics and is represented mainly by clustering algorithms. So classification, regression, and clustering are widely used in data mining. And we also have reinforcement learning, which is mostly used in decision-making problems like the computer playing chess. So independently of the applications, so machine learning techniques work in a similar way. The model learns from a training set and then becomes able to make inferences for a new data set. So now let's talk machine learning. We have talked about machine learning. We have talked about big data. And we want to apply now machine learning with big data, so we encounter some challenges. Why is that? A common machine learning presumption is that algorithms can learn better with more data and consequently provide more accurate results. However, massive data sets impose a variety of challenges because the traditional algorithms were not designed to meet the big data requirements. For example, several machine learning algorithms were designed for smaller data sets. So with the assumption that the entire data set would fit in the memory. Another assumption is that the entire data set is available for processing at the time of training. And this is not what happens with big data. So big data break all these assumptions, rendering traditional algorithms unusable or greatly impeding their performance. So a number of techniques have been developed to adapt machine learning algorithms to work with large data sets. Examples are new processing paradigms such as MapReduce and distributed processing frameworks such as Hadoop. Branches of machine learning, including deep learning, online learning, have also been adapted to overcome the challenges of machine learning with big data. So, as I have mentioned, big data are often described by its dimensions, which are referred to as its V's. And so early definition of big data focused on 3 V's, as I had mentioned: volume, velocity, variety. So a more commonly now accepted definition relies on 4 V's: volume, velocity, variety, and veracity. It is important to note that other V's can also be found in the literature. We also have 5 V's. However, which is value, the 5th V. However, value is defined as the desired outcome of big data processing and not as defining characteristic of big data itself. So for this reason, in this slide, you can see only 4 V's or 4 dimensions to characterize big data. So this provides also an opportunity to relate the challenges that we have mentioned directly to the defining characteristics of big data, rendering the origin and cause of each explicitly. So what I plan to do here is to identify machine learned challenges and associate the challenges with specific dimension of big data. So this slide illustrates the dimensions of big data, the 4 V's, along with their associated challenges, as I will further discuss also in the next slides. So as you can see on the top left, we have volume. This is the first and most talked about the characteristics of the big data. It is the amount, size, and scale of the data. In the machine learning context, size can be defined either vertically by the number of records or samples in a data set, or horizontally by the number of features or attributes it contains. Volume is also relative to the type of data. A smaller number of very complex data points may be considered equivalent to a larger quantity of simple data. So this is perhaps the easiest dimension of big data to define, but at the same time, it's the cause of numerous challenges, as we can see at the top left of the figure. So we are describing the challenges related to volume, like processing performance, curse of modularity, class imbalance, curse of dimensionality, feature engineering, nonlinearity, Bonferrone's principles, and variance and bias. So the next V is variety, bottom left. So the variety in what it represents, its semantics interpretation, and its sources. So although not as many as for other V dimensions, the challenges associated with this dimension have substantial impact. Then the next V is the velocity, which is the top right. The velocity dimension refers not only. So for example, with the smartphones and real-time sensors and the need to interact quickly with our environment through the development of technology such as smart homes, so velocity of big data has become an important factor to consider. And then the bottom right, veracity, so refers not only to the reliability of the data forming a data set, but also to the inherent unreliability of data sources. The provenance and quality of big data together define the veracity component, but also pose a number of challenges, as we can see the bottom right part of this slide. So here now we have the big picture of the approach and challenges that so includes a list of the approaches that we can take to deal with the big data, along with the challenges at the top that I described in terms of the 4 V's: volume, variety, velocity, and veracity. So as you can see from the table, there are basically, if you see on the left side of the slides, there are basically two main categories of solutions that I put here. So manipulations and learning paradigms. So the first category relies on data processing and algorithm manipulations to handle big data, while the second category involves the creation and adaptation of different machine learning paradigms and the modification of existing algorithms for these paradigms. So let's explore this a little bit further without going into much details looking at this table. So for the data processing and algorithm manipulations, so we usually have the work, we rely on an established suite of events, also known as this data analytics pipeline. So the approaches that we will discuss are possible manipulations in various steps of the existing pipeline. The purpose of the these modifications is to respond to the challenges of machine learning with big data. So the figure shows a representation of the pipeline along with the three types of manipulations to be discussed. So the data manipulation on the left, and then the processing manipulations, middle, and algorithm manipulations to the right. So these three categories, along with their corresponding subcategories, which are described below them, along with their corresponding enzymes. So I'm going to describe a little bit more in the next slides. So the examples are included are only actually representatives and in no way will provide a comprehensive list of solutions. So as you can see in this figure, so one of the first manipulations to be attempted in an effort to adapt big data for machine learning is to try to modify the data in order to mimic non-big data. So this modification takes place in the data pre-processing stage of the pipeline. Okay, so I'm talking about the data manipulation. Here is the data pre-processing stage. Okay, so two of the most important data-related aspects affecting machine learning performance are high dimensionality, so wide data set, and large number of samples, high data sets. Therefore, two intuitive data manipulation for learning with big data are dimensionality reduction and instance selection. So the term data reduction sometimes refers to both these manipulations, but occasionally specifically denotes instance selection. So, and additionally, we also have data cleaning, which is another important aspect of data manipulation. And to improve machine learning performance with big data, processing manipulations then focus on modifying how data are processed and stored. So now moving to, so we have discussed data manipulation, moving to processing manipulations in this figure. So here the term storage refers not only to physical storage on a permanent medium, but also to how data are represented in memory. So as I have illustrated in the previous slide, so processing manipulations can happen during three phases of the data analytics pipeline, which is data transformation, data storage, and data transformation, data storage, and data analysis, which is the middle part of this slide. So, sorry, I lost a little bit my thought as I was handling the slide. So in these stages, independent of the category of manipulations, process can be embedded to capture data provenance and therefore remedy provenance challenge. So an example is the reduce and map provenance developed for MapReduce as an extension for Hadoop. However, such process carries a significant computational overhead. So the mainstream of solutions from this category includes those based on parallelization. Processing techniques can take advantage of the inherent parallel nature of certain algorithms. So many learning algorithms such as brute force search and genetic algorithms are trivial parallel and therefore parallelization can provide massive performance improvements. So researchers have developed techniques and tools to parallelize machine learning, and two categories that can be distinguished, as we can see in this figure, so in terms of processing manipulations, are the vertical and horizontal scaling paradigms. So the vertical scaling up paradigm includes multi-core CPUs, supercomputers, hardware acceleration, which includes, for example, GPUs. The horizontal scaling out paradigms refers to distributed system where processing is dispersed over networked nodes. So as with the vertical scaling, processing is parallelized, but it also involves distributed nodes and hence network communication. So due to its capability to scale over large numbers of commodity nodes, so distributed systems have been the focus of big data research. So, and also the horizontal scaling, as you can see in the figure, has been developed into two streams, batch and stream-oriented systems. As you can see also in the slide, so we distinguish two characteristics, the algorithm manipulations and algorithm modifications as well, with new paradigms. So I'm now talking about algorithm manipulations, and then we have the modifications and modifications with new paradigms, which involve modifying some existing algorithms, applying process manipulations, and so on. Algorithm modifications have focused on modifying algorithms to improve their performance, while the algorithm modifications with new paradigms involves modifying machine learning algorithms to work better with new process manipulations and new paradigms. So I have discussed about the data processing and manipulation paradigms, and now I want to discuss about learning paradigms. As I said from this figure, so we had the manipulations approach to handle the challenges of dealing with big data, and then we had the learning paradigms. So I have kind of I hope you understood an overview of the manipulations, the different ways that we can do following the pipeline, and then I want to discuss some learning paradigms. So we have actually a variety of learning paradigms, but sometimes not all are relevant in all areas of research. For example, we have some only applicable to speech recognition. So what I want to present here are machine learning paradigms relevant in the big data context, along with how they address the challenges that I have been discussing. So the first of these learning paradigms is deep learning, which is an approach for the representation learning family of machine learning. So representation learning sometimes is also referred as feature learning. So this type of algorithm gets its name from the fact that it uses data representations rather than explicit data features to perform tasks. It transforms data into abstract representations that enable the features to be learned. So in a deep learning architecture, these representations are subsequently used to accomplish the machine learning tasks. Because the features are learning directly from the data, so there's no need then for future engineering. So in the context of big data, the ability to avoid feature engineering is regarded as a great advantage due to the challenges associated with this process. So deep learning uses a hierarchical learning process similar to that of neural networks to extract data representation from data. It makes use of several hidden layers, and as the data pass through each layer, nonlinear transformations are applied. These representations constitute high-level complex abstractions of the data. So each layer attempts to separate out the factors of variation within the data. Because of the output of the last layer is simply a transformation of the original input, so it can be used as an input to the other machine learning algorithm as well. So deep learning algorithms can capture various levels of abstraction. So thus this type of learning is, for example, an ideal solution to the problem of image classification and recognition. So the figure in this slide provides an abstract view of the deep learning process. So each layer learns a specific feature like edges, corners, and contours, and object parts. So deep learning can be used for both supervised and unsupervised learning. So in terms of also another learning paradigm that's suitable for big data, so we have online learning. So we have batch learning, and as its name implies, processes data in batches and requires the entire data set to be available when the model is created. Also, once generated, so the model can no longer be modified. So batch learning makes it difficult to deal with the dimensions of big data in terms of volume, variety, velocity, and veracity. So that's why we have, for example, online learning that use data streams for training, and models can learn one instance at a time. So it's a kind of learn as you go paradigm, and so alleviates the computational load and processing performance because the data don't have to be entirely held in memory. So this enables processing of very large volumes of data, deals with the curse of modularity, facilitates real-time processing, and provides the ability to learn from independent and identically distributed data, IID. So moreover, it doesn't require all the data to be present at once or located at the same place. So these paradigms also deals with data availability and locality. So also the online also reflects the fact that this paradigm continuously maintain its model. This is one of the issues with the machine learning, is that how and what are the mechanisms that we keep the model updated. So this online keep maintaining its model, so the model can be modified whenever the algorithm sees fit. So its adaptive nature makes it possible to handle a certain amount of dirty and noisy data, class imbalances, and also concept drift. And so the next one is local learning. So this figure provides an abstract view of the local learning process. So the idea behind it is to separate the input space into clusters and then build a separate model for each cluster. So this reduces overall cost and complexity. So it's much more efficient to find a solution for K problems of size M by K than for a single problem of size M. So this is basically what local learning is. So such approach then enable processing of data sets that were considered too large for a global paradigm. So now we have split the data into clusters. So another way of implementing local learning is to modify learning algorithms so that only neighboring samples influence the output variable. So dividing the problem into manageable data chunks reduce the size of data that need to be handled and potentially load into memory at once. Therefore, this paradigm alleviates the curse of modularity. Also, because of the locality of each cluster, models are not significantly affected by the challenge associated with class balances and data locality. So this is also a very good approach for big data analytics. Another interesting approach is the transfer learning. This is an approach for improving learning in a particular domain, which we call target domain, by training the model with other data sets from multiple domains that can be different from the target domain. So we use a bunch of other data sets that we call source domains. These source domains, they have similar attributes or features, such as the problem and constraints. So this type of learning is used when the data size within the target domain is not sufficient or the learning task is different. So the figure in the slide shows an abstract view of transfer learning. So we have different sources, and so we are going to use the data from the different sources and apply to a target domain. So the unique feature of transfer learning from other traditional machine learning approaches is the fact that the training set does not necessarily come from the same domain as the testing set. So also, it can train on data from several domains individually or combined together using regular or adapted machine learning algorithms. Domains don't have to have the same data distribution or the same feature space. So different elements can be transferred from the source domains into the target domain, like instances, features, feature representations, parameters, and some other kind of knowledge. So an example of a use case is, for example, energy consumption prediction for a new building, which is a target domain, using data sets collected from other similar buildings, which are the source domains, that probably have similar consumption patterns, but they are different in size and efficiency. So this is another paradigm good for big data. Another one is lifelong learning. So lifelong learning really mimics human learning. So learning is continuous. Knowledge is retained and used to solve different problems. So it's direct to maximize overall learning, to be able to solve a new task by training either on one single domain or on several domains together. So the learning outcomes from the training process are collected and combined together in a space called the topic model or knowledge model. So in the case of training on a heterogeneous domain, so then transfer learning might be used in the combining step to create such a topic model. So the existing knowledge in this topic model is used to perform a new task, regardless of where the knowledge comes from. So lifelong learning is related to also online learning, So because like in online learning, lifelong learning is a continuous process. And the difference is that online learning will consider only a single domain, and lifelong learning will include several domains, may include several domains. So lifelong learning is really kind of a combination of the transfer learning and online learning that I have discussed here. For example, when would this be useful? Let's say that consider the process of like inferring individuals' sports interests when various data are available, such as the physical location, social media interaction, weather data, and web browsing history. So the prediction of individual interests needs to change periodically over time when new data become available, because the area of interest may shift over time. So as you can see, the figure here shows a high-level view of lifelong learning. So lifelong learning is a good candidate solution for big data, because the model is continuously refined and the learn task is applicable to different domains. And the last learning paradigms I want to discuss is the ensemble learning. So ensemble techniques attempt to build a set of hypotheses and combine them to form a new hypothesis. So ensemble learning combines multiple learners to obtain better learning outcomes that can be prediction classification than those that would be obtained from only one single learner. So the figure in the slide presents an abstract view of the ensemble learning process. So typically the overall outcome is determined by a voting process among the weighted outcomes of individual learners. So here we have three learners, L1, L2, and LL. And so then we combine typically the outcomes of each of these learning, then to come up with an output. So in terms of the individual learners, they can be similar or from completely different categories. Include those belong to supervised and unsupervised machine learning. So this weighting mechanism assigns a value to each learning output point and combine them. So the voting process could be implemented in a straightforward way by directly aggregating the values of the learning points, or through the use of statistical techniques to obtain a combined value of the learning outputs that may lead to better learning performance. So I kind of provide, in no way this is all the possible learning paradigms, but I try to give a glimpse of the suitable learning paradigms for big data. So what I want now to discuss briefly is about the projects. And so here we have one project that I have developed with London Hydro, and what we basically want is to provide data analytics service for energy management. We use some data provided by smart meters data, and we have generated some real world applications that have been used for London Hydro customers. So as you can see here, we kind of then use also software engineering techniques, and then we are able to come up with several research projects that students have been worked on. Another project here is a sustainable management platform. So the cloud platform that is based on services, and we automate building management activities to optimize resource consumption, and we also enable the integration of third-party application and app store. So the research topics that were involved here are big data analytics. We have done a bunch of using many machine learning algorithms, and we have done prediction, anomaly detection, and also complex event processing. This is another project with another partner, and we want to extract business insights from the data they have been collecting from mobile devices. And so the idea was to increase revenue from online advertisement. So we targeted advertisement to contextual user segmentation. So yes, many students have developed researching on big data analytics, using several machine learning paradigms and recommender systems, and also click-through prediction. So with that, I would like to conclude my presentation. And so I hope that I have presented the challenges of big data, and then some solutions that we have worked to deal with the challenges of big data. And I have also tried to give you a glimpse of some projects that we have worked with industry successfully. Thank you very much, and if you have any question, please feel free to email me.
Welcome everybody. My name is Mario Dantas. I'm a professor from the Knowledge and Engineer Laboratory, Department of Computer Science, Federal University of Juiz de Fora in Brazil. The keynote today is going to be related to data-intensive scalable computing, DISC. So before I start, I'd like to introduce you for my background to understand and what I'm going to tell you today. I'm starting my work almost 36 years ago in the industry, and then I moved to a research center, the petroleum engineering, and then afterwards to the academia. In this time, during this period, especially when I was there in the industry, research center in petroleum industry, I used to work with high performance computing, where we are working too much oriented to computing, in terms of computing fast, computing a large amount of problems, and nowadays we are thinking about more in data. Of course, we're still working with the computation part, but one very important aspect now is the data. So the research that I'm doing in this time is distributed scheduling in parallel distributed environments, ambient assisted living with IoT, software-defined network, quality of experience, quality of context, distributed and parallel storage, Orange AFS, HDFS, and smart cities, big data, HPC, and DFS. So our agenda today is divided in 5 items. The first one is introduction. I'm going to introduce the problem for you, the environment. I'm going to tell you about big data in non-fashion way, usual way. I'm going to point out the importance of storage. You are going to see that is a key point, a key element in the talk, and also for you in your day. And we are going afterwards to do a comparison between HPC and disk, okay? And finally, the conclusions. So to start with our introduction, I'm going to share with you this picture that is 33 years ago when we were in the petroleum Brazilian company, Petrobras. and we are starting to do the first connections of machines, computers, to gather those in terms of facilities, to share facilities between those computers. That nowadays is very usual, is very ordinary, but that time was not like that. In the 988, we have they call mainframes, supercomputers complete split over one from the part of the other, and we don't have this kind of thing that we have today, okay? And the next picture looks like papyrus, is a paper that we published 32 years ago, and a computer graphic network for offshore engineering. What is this about? To share computer facilities, share application software, allow modular growth, integrate activities, for instance, provide access to computers, and provide connection to SNA network architecture from IBM. In that time was the top. And as you can see here, the data was not too much important. You have here one picture that the connection was important. First of all, the connection from, this is a several parts of Brazil. Brazil is not a country, actually. Brazil is actually a continent. You can put almost the entire Europe in Brazil for you to have an idea. And these connections to us is very difficult because we are talking about 32 years ago, and connect the northeast from the southeast, from the south, we are very difficult. So we are tackling in the first time this connection. In terms of connection, these nodes here are connection spread over the country, and we have in some places high facilities in terms of let me say a medium, not large computer, but a medium computer that connect to another one and does this, that. And we are not living this period anymore. What we are living now is this facility not spread over regions, but spread over persons, spread over cities. That's the main focus that we are going to talk with you today. But this is a very nice piece of old-fashioned piece of paper, okay? In this talk, we are presenting an approach called a DISC, that is acronyms for data-intensive scalable computing, that focus on type of data-centric application, okay? Different from, for example, web and business, but we are oriented toward management and data analysis, and has the goal to scalability, fault tolerance, availability, and cost performance. What we're trying to say here is that we are thinking about more about the data as a key role for the application, not the connections, okay? The connections, we understand that exist, already exist. I showed to you that paper from 32 years ago. So the paradigm, considering programming models that used to say is the ordinary ones that use high-level operators like language Java, Python, Scala in a conventional hardware clusters. Again, we are using ordinary off-the-shelf environment, hardware that is off the shelf. And also, we are going to share some experience of experiments and experts in HPC using this approach in interesting industrial case studies, because we from HPC arena, usually we didn't take too much care as we are moving now in terms of data-intensive scalable computing, okay? So what are the areas that can benefit from this type of research? This is a very interesting point. This is, I used to say, the start question of the research. In this point here, the questions of the talk. All those data-intensive context-oriented application. Data is the focus. The data is the main actor in this kind of effort, okay? So in the past, we used this kind of the workflow to trying to explain things that we are doing. We have big problems leaving us to looking for large computing demands. Computing demands push us to research and new developments, and afterwards enhance the computer power that could also, of course, help us with this big data. Okay, so we are here again in the big problems. So the workflow is completely, but what changed from the past? This is, of course, a workflow from the past. We didn't take too much care as we take nowadays about the data. So here we have the large computing and data demands. Okay, I'm going to show to you during presentation that the data could not be treated as a very static element here. No, the data is something live that comes in a very huge amount, and of course we should treat the data to transform this in information and afterwards acknowledgement. Okay, so from where to the data comes and goes from and to. This is very important. In the past, we have such kind of very, how can I say this, ordinary way to put the data in our computers, and the people from punch card, from digitalizing, that's good. But how we can get those data nowadays, how they are actually collected, and how we can transform the data and gather this and put this to be used for the final users. Okay, so this is a kind of example that I mentioned before in scientific area that you have in high performance computing, the CERN Large Hadron Collider, LHC. We have around 25 gigabytes per second and 30 petabytes per year. Okay, another example is the Australian Square Kilometre Array Pathfinder, very well known in the area of high performance computing. We have 2.5 gigabytes per second and 75 petabytes per year. Okay. The another one is from the Sandia National Laboratory in US, the 3D direct numerical solver called STD. The simulation of turbulence combustion. We have around between 30 and 130 terabytes per execution. This is one collaboration that I have mentioned, and I'm going to tell you about what we have with Japan. This is an atmospheric model where we have the global convention simulation atmospheric, okay, with the high resolution of 870 meters, and we have around 30 terabytes per execution. And now this picture here is a picture of disruptive in terms of what we have saw so far. Why? Because we are talking about big data in agriculture. We are talking about a large amount of data in an environment that we never ever think that we could collect those kind of information. We have here some telemat device, for instance, 25,000. We have here the weather stations. We have information from the crop. We have a lot of things that are completely new in terms of course, in terms of years that we are collecting, we are storing, we are producing information and knowledge that we never had this before. So to work with the data, we should understand that the data has a huge amount of requirement process to be clean, to be usable. Okay, that is one important that you should start to looking for. So big data. I have a friend in Japan that used to say, big data, big data, big data. Nobody knows what's big data, big data. Yes, this is true. People talk too much about big data, but big data should be understood more in detail. And I'm going to provide you a view, more ludic view about that, to bring you to my side to understand the problem, okay? The actual scenario is like that, increasing synergy between high-performance computing that used to be a castle, where scientists, engineers, physicists, people from science were there using their facility without bringing this to, of course, only the results, but these are very expensive environments used by a staff, select people from a very high level in the universities, in the in companies that used to work this for the petroleum engineering, aircraft, or something like that. We have the big data, that is our big problem, and we have the Internet of Things that actually, when I mentioned before about punch cards and digitalized things, the Internet of Things is the new element that where we gather the data from, okay? So if you see here, it's like something like that, the Internet of Things, the many interests, then we should work with the big data to, of course, to store and provide the right I/O for those guys in high performance computing. And now we have the disk, the data intensive scalable computing that are more generical, okay? Kind of problems that we are working with ordinary, for instance, day problems. So the convergence of the platform is something very interesting because the data comes from a variety of data, sensors, a variety of sources that are not usual, and we should tackle this kind of problem. Yeah, of course, the new computational demands are completely different than what we have in the past. So we have a lot of applications that they call time-constrained application that you submit and you want to have this answer as soon as possible. So this is, of course, one example, and we should understand and tackle those problems, okay? And the another scenario, this interesting to mention, is artificial intelligence, machine learn, and deep learn. Those kind of tools, those kind of algorithm applications are very, very important. But however, if you don't know which kind of problem do you have, which kind of research question do you have, the artificial intelligence, machine learn, the deep learn are not going to help you. So to help you, we should have data, okay? And this data should be clean, this data should be well organized to provide what we want, the right question for our research question. So predictions of considerable growth in the volume of data produced and consumer, this is actually one actual scenario that we understand, we realize that, we see this day by day, okay? And so some examples are the study for large companies, IoT corporations such as Cisco and IBM indicated that 2.5 exabytes of data per day. They are foreseeing that. In this year, it is estimated that this number will reach, for instance, 40 yottabytes, which means approximately 5,200 gigabytes per each person on the earth. First question, where are you going to store this? The second one, which kind of process we are going to, what kind of process that we are going to execute to provide information, then afterwards provide the acknowledgement that is required. If we don't have the idea how to do that, the information is not going to be available. The data for per se is not a value. We should understand that. That's because it's important to understand how to treat the data, okay? And the big data approach considers 5 parameters. You can argue with me, Mario, I have saw 7 V's, 9 V's, but if I could understand this 5 here, of course, the others are derivation from that. The first one is volume, the amount of data that you have that we mentioned before. The velocity. Are you able to tell me the velocity of your mobile device to connect something there? Or are you think about, oh, it's 5 gigabytes, 7, 20 gigabytes, no, 80, 100 gigabytes. But gigabytes is a matter of size, is not a matter of velocity. So this is another kind of puzzle that people sometimes don't realize. So the variety also. If you are thinking about to keep the data from you as a person and your home, your city, your neighborhood, oh, the variety is very, very huge. And we should tackle this in terms of standardization, in terms of filtering, in terms of proceedings to get the best of this variety. So the veracity also is a very important thing. Security is very important, and we are, of course, as a community trying to work with a lot of solutions. And then afterwards, the value. Which kind of information I have in my environment? It's not necessary to have, I don't know, 30,000 measure of something there if nothing have changed. So which information I can provide to you in terms of value if I say to you that I monitor you in your smart band and for the 20 years, 40 years, and we're going to keep a lot of data there, and this data could not be valued because there is a lot of rubbish there. And we are going to show this afterwards, okay? So the challenge of the big data approach can be measured by basic questions. Like the first one, can my organization store, manage a large amount of data? The second one could be, can we guarantee, for example, the velocity under a specific period? Like we are living now with this problem with coronavirus. So we used to say this I think it's a more appropriate to say time constraint. What's the time constraint that I can provide to my application under this kind of problem that we are living now? Okay? So the other two questions, interesting questions, are how to treat such variety of technologies. We have a variety of technology involved, and we have a melting pot that should be very well organized to provide, again, information, to transform the information, acknowledgement. Data should be work as a base and a very good base for that. As the other one is, as for veracity, can I check it? Can I check if this information that is receiving by my doctor is from my smart band? Is it true? So this is another point. And of course, we have mentioned before, can I quantify the value? Can I get it? Or how can I get it? Okay? So moving on, after putting you a scenario what big data means in terms of real, a real environment, or if you prefer the ground floor that we should put our foot there, we are not forgetting the storage. Storage is a very, very important key element for the big data. Why? Because if you see this question here, how do you perceive the entry into the system? Are you think about punching cards or you think about sensor? Nobody you're going to say, oh, punching card, no. But come on, you are not consider sensors. Most of the people are still considering typing the data, or the data is there like a def element and it's provided to me and I can get this. This is not true. So our scenario nowadays is that we have the sensors. It could be this, like this one smart band, could be one in the vehicle ad hoc network, in VANET. We can get a lot of information on the smart city, and we should work with this data. Okay? And one important thing to work with the data, first of all, is how we are going to store this. And I have this in my classes, and I can provide an idea to you that I think is nice, how to treat this storage in terms of how we are going to organize them. For instance, here I have one beer query, for instance. I have this beer, a very good beer from Belgium. They call Deus, means God. And of course, if you see here, I can see the beer stored at home. Oh, there is no beer like that there. That's easy to find, okay? And here, again, if you see the beer storage professional, I call way here, is very, very well organized. And you could very easily go to there and say, oops, there is no Deus beer here. Okay, but these two examples here is very important to you to understand. First of all, my beer store home is a very small one, well organized if you prefer also. And this professional storage here is also very, very organized. But what you see in the field, what you see really in our day-by-day basis is like that. I put like that here. How is your information being stored? This is not a kind of joke. This is real. I put this in the terms of you can, of course, see the figures. So you have this very huge amount of data in the garbage here, and the mix of word, papers and something like that. Or you can tell me, oh, in this second one, the second one we can consider people who are more organized and put the garbage in such kind of environment, but still garbage. And here, this one, too much. You have two garbage, very large, and the data, in this mean the data, is here leaking from the equipment, from the containers, okay? What you'd like to have is this one here, a well-organized place that you are going to put the blue things in the blue place and the red one and the green ones so forward. And also the type, the size of the garbage that you need. You can have one for the kitchen, of the green or green bay, and so forth. If you think about your laptop, you can tell me, true, which kind of approach do you have? Do you have this one here, this one, or you have one of those? Okay, the data usually is not well treated by the users. Okay, so, and the amount, again about the amount, in 2016 we have around 16 in terms of course we are talking zettabytes. In 2025 is expected to have 163 zettabyte of information from devices like the cars, the health, electricity we can have from the equipments that we have inside the home, and so forth, okay? So the zettabyte projected size of the global data sphere in 2025 is like that. We are going to have, for your have an idea, watching the entire Netflix catalog 489 million times, or if you prefer, 40 trillion DVDs. That means which could reach the moon and back over 100 million times. So think about that, this number, and again, see this picture here, where we are going to put all those data, okay? So another aspect, very important when we are talking about that, is that people used to talk, I'm going to put my data in the cloud. Cloud is not the appropriate place to put the data in the first action, okay? We have this infrastructure that is being used for not a long time, but for a time from specialists that we have the smart objects where we have kbytes and gigabytes. We have some processing here. So we have fog layers where we are talking about gigabytes or terabytes, okay? And afterwards, this is the core networks is responsible to, for instance, to move data on from terabytes, petabytes to the clouds. When you have this here, this stage here, we are talking about the small data that are gathered and put together to have improvement in terms of utilization of the bandwidth of the network, and then afterward, well stored there. Because if we don't do that, remember this picture here that people use, don't like it? We are talking, this is a cloud without work. This could be a cloud when we work like that, processing the data, organizing the data, and send this up, okay, in the infrastructure. So another point very interesting is like that. People, I put here a question for you. How do you understand the system storage? Many people think about hard disk like a wardrobe. Some of those think about wardrobe very organized like that. That's not usual. And though some others think about the storage as a backpack. And this is right. The DRAM, for instance, the NVRAM and SSD with a very short time to access the data is nice. But to have a backpack is not exclusive for you to not have the hard disk or to have the wardrobes. If you are traveling, this will be your storage, okay, equipment. If you are at home, probably this is going to be the best. So this is a kind of thing to break in your mind that storage is something that is done. We cannot move this, we cannot adapt this to what we are looking for, okay? And this figure here is only to show to you very high level that nowadays work with like that is my area. We work with processing, that in Portuguese we say processamento, and we used to say armazenamento, that is storage. Also, in other words, what I'm saying is that nodes, computer nodes related to processing, they use only the feature to processing. Afterwards, they send information to nodes that take with the I/O, and those nodes I/O send this for a metadata servers that are going to choose which kind of device is going to be the storage part. As I mentioned before, when I talk about storage, I'm talking not about the device, but about this here. Nodes that are able to provide very fast an I/O, and which are going to direct your data to nodes that are going to provide the information which is the best device is going to storage your data. Okay, so the crucial point here is demand for I/O scalability. So of course we should have a storage capacity. This is quite clear. This is quite how can I say, easy to understand, but the access performance is the key point. Doesn't matter how much amount of data you have there. The point is, I want to have the data as soon as I want in my application, okay? Like you are in the library, you are looking for a specific book. If you don't have a very good index, okay, you are not going to have this book as fast as you want. The other point is, in modern high-performance computing environment, they are using already multi-layer infrastructures, like I mentioned before in my picture, and also high distributed secondary storage systems. Why? Because they understand that. They clearly understand the data are storage capacity and access performance. That is important. And what we're telling this repeatedly to us, because when we're talking about data intensive scalable computing, we are talking about applications that usually are ordinary applications that we don't have a high performance computing environments dedicated to provide this kind of infrastructure to us, but the guys there should understand that this kind of approach needs or it's required to exist. Okay, so here again, only to perform you an example, I have here one application, computer client that is asking, oh, I want to gather my films and my photos from the last vacation. Go straight to a server that understands the question. This is a processing node or client, if you prefer, client in terms of storage, and send this to the guy who is in charge with, and send back the information, and the guy can connect directly. Oh, here I can get my photos, my films, or whatever, my data, the information about the trip, my bills, or something like that. We are working a different way nowadays, okay? This is a picture that I like too much. I'm going to pass very quickly because you probably you will not understand how we love this, but it's important. We have the blue ones that are nodes or computation nodes. We have these dashes here to understand that the middle will have the nodes of the entrance, the I/O, okay? And then afterwards, those red ones that are going to take care or going to face the storage device. Storage means nodes that are able to redirect the information or the data that you want to keep to this data to data or data or metadata servers that are going to talk directly with the equipment. That storage. When we are talking about storage, again, we are not talking about disks. We are talking about the complexity of those things here. Nodes that pre-process your information, redirect to a more large metadata servers that understand where are going to put your picture, your speech, your text, and when you require this, very fast is going to be answer for you. But let me tell you something. Without your question of research, I cannot do this. You should tell me which kind of pattern you have there, which kind of requirements that you have there. Then afterwards, as a specialist, we can provide to you as much as possible the quality of service that you want, okay? So there is a lot of kind of tools that I'm saying, distributed file system like LoRa and GFS. I'm going to provide the talk, so you're going to see where the client, you have here a program that has a client that asks for where is my data, where I can do that, okay? So these guys here are going to provide an answer to him, the number 3 here, and say, oh, you're going to pick the object here, object there, and point it to you where you're going to do that. There is another architecture like Lustre is a very famous one, very useful also. They have the Lustre clients and you have the guys who are going to respond to you. And this is another kind of infrastructure that I don't want you to be masters, but you understand that, oh, this guy is telling me that storage provides me a better environment to provide my application the appropriate big data solution. Yeah, that's true. That's okay. So now we are moving to differentiated HPC and disk to you to have a solid information about this. So the data-oriented world that we are living, I split over in 2 pieces. The first one is science. Database of astronomy, genome, seismic modeling, and other fields like I mentioned before, and I showed you 2 pictures before. So like you manage it also, historic documents, film, scan of part of the object. If you are from a large entity of our organization, you are welcome with that. Oh yes, I know that. But where this is a kind of subject that you use to use high performance computing. But if you are not from this area, or if you are not using this, of course, you are in the another side of the coin. Could be the commerce. For instance, corporate sales, market transactions, product sales via web, or the health. You can have the radiographic, resonance reports, entertainment, for instance. And how we are going to do that? We are going to use a cloud without understanding how we should keep the data, or should I and you understand that, oh, come on, I'm a guy who has a small company in entertainment with music. I should tell the guy there how I can provide the best service, for instance, for my clients, or even the documents for my clients, and I would like to have this kind of pattern here, okay? So you are responsible, again, for which kind of question your research, which kind of question is your requirement to me to provide you the appropriated answer, okay? So if you understand now, until now, I'm going to show this, but let me tell you something like that. When I talk about high performance computing, we are talking about castles, where very large organization, very large laboratory from the government, from very huge amount of money from industry, like automobilists, like aircraft manufacturers, they have there. And the disk. The disk is ordinary people like me and you, for instance, that immigrate to here. And then we want to understand how we can work with this amount of data that comes from my smart band, come from my car, from the information, the sensor in my house, in my city, okay? So these 2 next slide, I'm going to tell you about that. The focus. In HPC, we are computer-oriented. In disk, we are data-oriented. We are working to provide to you, or to allow you, to inform you the data is very important. So take care of the data. Take care of the caption of the data, how it's entering the system, how we organize, how we can do performance to provide information, and then the treatment, first one, and then acknowledgement, okay? So in terms of applications, again, HPC, we are talking about science and engineering, for instance. In the other hand, in the disk, we are talking about web and business. We are more wide open. You can tell me, Mario, but there, the first slide, you tell about web and business, like we are not too much worried about data. Yes, but now we are talking the data in the same as in the same level as we have in before in the past with scientific and engineering. Okay, so the target of high performance computing is simulation. We talk about simulation to afterwards provide something more effective. And here in the disk we have the management and the data analysis. Okay, another thing is the objective. In HPC we are dealing with high performance, and in disk we are not too much working high performance. We are worried, but not too much. But scalability, the fault tolerance, availability, and the cost performance for us in terms of the data. Okay, so the programming model, usually in HPC we are using low-level libraries like MPI and OpenMP that are very oriented to a scientific area, and operator libraries. Okay. On the other hand, again, the disk is high-level operated that ordinary programmer can understand that in map, reduce, filter, join, unions, and etc. About the language, again, we have the HPC C, C++, and the disk. Again, very popular language like Java, Python, and Scala. In terms of architecture, it is the final remark about that. We have the shared disk and the specific hardware to solve problems of high-performance computing from scientific and engineer, for instance, example. In the disk, we are using, we call this in computer science, sharing nothing cluster, commodity hardware. We are not worried about the machine in terms of reservation. When we say sharing nothing, we are doing what we want using this kind of environments, okay? So this is another very interesting thing to differentiate the approach of data simulation analysis. In terms of high-performance computing, we are looking for post-processing because the amount of data in scientific engineer, for instance, areas is huge. We have performance analysis after the simulation. Simple, non-intrusive, however, for batch analysis. Okay, this is a partnership that we have with Japan. For instance, here we have such kind of way to have an input for a K computer. It used to be one of the fast computers around the world. And then afterwards, we save the data very carefully in a global file system that provide the answer for this high graphical user interface, or can provide to this one that you saw before, the entire world here in the theme of atmosphere. Okay? Very interesting because the amount of data generated is very, very big, and we should have the data simulation in this kind of cube that we have here to provide to the specialist information that they want very, very fast. Okay, so the entry here is a kind of input bed, and the output is image that we are providing to them image. So what I'm saying that this kind of organization that we have here is exactly that I want to have for you that we're using a smart band, a smart city, intelligent car, whatever you want to provide the right answer for you when you need it. Okay. So there is another one that called in situ analysis. This could help you also because you can execute there. I can tell you this is very, very large one. Okay, this one could be a medium. You can understand like that. It's intrusive. Okay, however, it's used to performance and a filter. Okay, that's good. And for us, think about data intensive. Sorry about that. I put here in Portuguese. That the same thing, the approach of simulation and data analysis. Here is the last one we call in-transit analysis. Transfer the analysis to a separate portion of resource. For example, using a single cluster with a computing nodes and data nodes. Less intrusive than in situ, but requires a careful synchronization, simulation, and analysis. In other words, this is more easy to us to provide data in a more accurate way to a software that is going to provide the information and acknowledgement that we required in the end of the day. Okay, and what are the existing scenario in the disk? Let me say approach. What are the tools are using? usually used. Okay, this is a very interesting one. We don't have the landscape 2020, but we have 2019, where we have a large different kind of types of interest, like data flow that used to be scientific, ATL, massive parallelization also. But we have here, for instance, data logistics. We have here streaming processing. This data enter here, and then we have in this side here, we used to say the data lake. The data lake is like we have a lake of data. You have your mug, you put there, you can drink the water, okay? And you can have another kind of different mug and take that. What I'm saying is that the data is organized in not a specific way. Is organized, but you are going to tell me which kind of way you wish the data. And here, this side here, we have the data warehouse. The data warehouse different from the other side. We have here, if I compare the lake that I was mentioned, we have here the water in bottles, different kind of bottles. The first one is NewSQL, where we have the conventional database and those that are not conventional database. We have in-memory, for instance, database or time series database. We have different kind of bottles. You have different kind of software that are going to provide the information exactly that I need there. And in the final level here, we can have, of course, data science, we can have interactive analysis, and we can have reported dashboards that are very interesting for a variety of things. We are working a project that the streaming coming here, also data comes, and we are storing this in the HBase, for instance, or Cassandra, and then we put this for the user that can access in this dashboard very easy the data as he or she wants to do so. Okay? So, conclusions. Final. So, be concerned with the aspect related to the data entry and exit. This is very important, very, very important. Data is not a garbage that you throw there and go. Okay? This is it's a very important to you to understand how to capture the data or asking for somebody to understand that with you with a special focus on filtering, type of IO nodes and storage device. Storage device are part of the history of the storage, as I mentioned before during this presentation. And focus on the filtering, why? It's not true that you have the sensor, for instance, in a house and you're going to keep or to gather all the data very, very fresh, because probably your house is too much cold or too much in an appropriate environment, and we should understand the data that we are capturing from sensors should be filtered. Okay, it's not necessary to you capture information that doesn't move. The data from this room that I'm here, I have the light on for more than 20 hours, let me say 24 hours, still there. If something happens, so the data is going to be changed, so you filter, oh, the light was turned off, okay? So develop studies on how to best store the data for different applications. This is very important. And if you are involved, and you are involved, of course, you are a person, you are a researcher, you are a professor, student that are involved with a study, and the data should be serving you, but you cannot neglect how you are going to store and provide to you the opportunity to transform information and knowledge. Okay? Seek to different tools for different computing challenges and storage. I am saying that because I'm a specialist. I have been working, as I mentioned before, for 36 years, and you have some fans of some kind of tools, and they want to use that tools for every type of that situation they have there. That's not the case nowadays. We have a lot of different kind of environments, like I mentioned before here. In this picture. So you have different kind of applications, different kind of software that are very important to you to take care of that, okay? So using the appropriate simulation approach, if it's post-process, in situ, and in transit, I'm going to bet here, probably most of you are going to use it in transit. That's very nice, off the shelf, okay? So considering the HPC and disk approach in appropriate situations. If you are, of course, working with scientific engineering, biology, or something like that, we are talking about this HPC. And here, it's not a kind of good and bad. We are talking about a more relaxed kind of application that oriented, let me say, to more to our ordinary life, day-by-day life, for instance, or business, okay? In the data scientific, sorry about that, in the data intensive scalable computing approach, consider using different software again for different challenges. Again, I'm not repeating myself. I want to leave this also for you, that I have a lot of experience with that, and several projects are not, how can I say, well successful because people are using old kind of tools for this kind of new environment that we have nowadays. So Hadoop, MapReduce, Spark, Flink, Kafka, I don't know which are the best for my challenge. Okay, saying that, I have here the reference, and I'm open to tell you if you want more. Think about that. You can send me an email. And thank you very much, and appreciated very much your attention for my keynote. Thank you very much.
Hello everybody, my name is Paulo Cauchete Miguel. I'm here to present a paper, Data Management Plan in Research, Characteristics and Development. We have also other co-authors, Susana Moro, who is from Federal University of Santa Catarina as well, and Roberto Rivera and Marlene Amorim, who are from University of Aveiro in Portugal. First thing is presentation outline. I will give you a little bit about the context and motivation and objective of this work is related to research data management, industrial engineering, and the main focus is on data management plan. Then a brief literature background on those subjects, especially emphasizing RDM and research life cycle. And then research procedures, steps for data collection and analysis in this particular work, which is a work in progress, and then results that I'm going to show some examples and recommendations, especially from the literature, because this paper is a theoretical, mostly a theoretical paper. And then summary and future work we intend to do, and finally the acknowledgements. So going into the context, motivation, and objective, we know that data science is a broad and interdisciplinary domain presenting various fields like biology, engineering, IT, and many others. And one of the relevant areas is research data management, that we have to deal with data along the course of research. Data collection and analysis procedures are usual practice that performed by research. However, other stage in the data lifecycle is not usually addressed in the same extent. This is particularly important in the context of research methodology for industrial engineering. Both are one of my main areas that I usually work on. So the objective of this paper is to highlight characteristics with regard to data lifecycle, focus on research data management plan. This is the main unit analysis of our paper. Firstly, a brief literature background. It's something related to RDM, or research data management. We know that data exposes to risks during its life cycle. especially when we're talking about a research project, and then those risks can affect their interpretation. RDM is a process that requires anyone to create, organize, keep, find, and share data, because it ensures that the process used by the researcher to the life cycle is organized, clear, understandable, and that could lead to a reproducibility of data. RDM lifecycle visualizations could be helpful for many different stakeholders in order to understand what they have to do in terms of tasks, responsibilities, structure, logic, and order of research activities. Alternatives of data management lifecycle literature usually includes those. There are different ones, but usually includes those main stages: create or collecting data, processing that data. Usually you have to interpret the data and also analyze the data, which is the following stage, and then preserve data, because you could use those data in the future. And also for doing that, you have to providing access, which is very interesting and very more and more common nowadays. And then you could reuse the data to conduct new studies. RDM is still a challenge for researchers and institutions, and that this is amplified because of the role and the current role of digital practice in terms of research activities. This is a very interesting figure that represent hypothetical research and data life cycle. We see in part A the hypothetical research stage, and in part B the data life cycle, and we have there when you take a look into the data life cycle at part B, relevant points, and then for each stage, for example, for the planning stage, we have relevant points which are listed, and those that are yellow marked is related, for example, for that particular stage in part B, which is the plan. It's related to determine the sponsor requirements, define policies data, assign roles and responsibilities, and prepare a budget. So those relevant points are further discussed in another paper, which is the source is Michener, 2015, and I will get to there in the end. So that figure particularly represent the relationship between the research stages and also data life cycle. Going into the research procedures, what we have, the main steps of our work. First, we establish the main scope of the work, which is a research data plan, related to research data plan, and then we collected data. We collected data through a literature search, especially peer-reviewed journal on data management subject and data management plan. This, remember, that is ongoing work. Part of this result is in the theoretical background of our paper, but we're still working on the content of this literature search. We also access secondary data from relevant institution, for example, European Commission, and then to analyze data, we describe data management plan contents, which is the main subject of our paper, as I said before, and check the fit with the research data life cycle. And because it's a theoretical paper, we use the literature to do some recommendations on that, and also apply a retrospective procedure, and also identify and discuss relevant points which are related to the scope of our work. Example of sources you can see articles in peer review literature, mostly journal articles, but also selected conference papers, And then we use non-peer-reviewed material, for example, secondary data from Horizon 2020 from the European Community, and also secondary data from Digital Curator Center in the UK. Examples published by practice we also apply. For example, I will show you, in a little bit, a part of data from a data plan from the University of Aveiro. And we have to bear in mind some relevant points in that particular work. We have here short and medium terms goals. The first one is raise the problem of data management lifecycle within our community of industrial engineering, and then a long term we intend to take that knowledge related to data management plan to help beginners, researchers that are beginning this work in dealing with the subject. So going to the results and discussion. First, we can see that a guidance for building a data management plan from Digital Curation Center in the UK. So we have some phases. Administrative data is the first phase, when you have to get all document information, usually basic information, but relevant information. And then data collection. We establish procedures how to collect and gather data, and then documentation and metadata, which provides information for data reading and interpreting. And then we have to consider also ethical and legal compliance, and perhaps other constraints for data sharing, for example. And then you have to storage and backup, where to store the data, access, how to provide access, and the aspects relates to the safety of the data, security. And then we have selection and preservation of those data to be used, for example, in the future by other researchers. You have to take this decision as well. And then data sharing, how to those data will be shared, and how you provide availability for reusing, and so on. And also responsibility and resources that should be assigned to this particular data management plan. More details on that is in table 1. There is a summary in table 1 of our paper. So the example of administrative data from the University of Aveiro, we have there a project idea template that you usually use by the university. And the first part, for example, left hand side on the top, we have a basic information, for example, title of the project, how long the project will take, deadlines, final deadlines, partial deadlines, contacts that are related to that project, priorities, and so on. And especially on the right hand side, we have summary and objective, a description of the project, objectives, outputs that are expected for that particular project, proposed partnership, and or partners that are needed to complement the workforce of that project. The example of this is available in the paper at figure 3. This is a extract of a checklist from Digital Curation Center. It's a very interesting checklist because it takes that phases that I just showed in the previous slides and get things that are important to be in the data management plan. For example, administrative data, as I said before, are those related to establish who is the founder, a grant number, description of a project, research project, research name and IDs that people who are involved with the project, data, policies that are using, etc. And this, in terms of data collection, there is only one part of this checklist. Is not a long checklist, but is a very good checklist. But for data collection, we have more information. I'm showing just part of that information, what data will be collected or created, and also how the data will be collected or reused, for example. Finally, this last slide of the results, what we have here is a guide for an effective data management plan, is relevant points that should be considered based on that reference. This is related to the figure I presented a couple of slides behind. And then we have, this is available in the paper at figure 1. And then we could list things that are important: disseminate the research sponsor requirements, identify data to be collected, how data will be organized, documentation of data, quality data assurance, and then present aspects of storage and preservation, define the project data policies, how the data will be disseminated, assign roles and responsibilities, and also prepare a realistic budget. So those are relevant aspects. What we've done in this paper, we construct that figure based on that reference and put the main points as a summary in each of those relevant points. So going into summary and future work, so it's common knowledge or common sense that there is a sharp exponential growth in the amount of data, and that this leads to, it's crucial to ensure knowledge of research and try to get the best practice in data management during research, not only during research, which is more common for us to do, but especially after when we complete that particular research. So all stages of data lifecycle should be considered, especially due the demand for funders. This is not happening at the moment in Brazil, but this is more common in projects that are submitted to European Union, for example. So, and for us here in Brazil, it's important we take those other stages into consideration. So this work concisely explored those characteristics, general characteristics of the life cycle of data management, especially for research, and when discuss aspects of data management plan. And we expect that this is expanded our discussion in the research practice, especially in our field, because many parts of the data life cycle we don't usually deal with, and we understand now that we must do that. And further work may consider provide guidance to students, for example, and also to our peers, and raise what would be the best practice for data management and for both research students and peers as well in our field of industrial engineering. So thank you very much for your time, for listening to me. I'm sorry for some mistakes, and it's a shame that you could come to Florianopolis. It's a very nice city for those who've never been here. So I expected truly that you could have an opportunity to come here again. And all the best to you all we're facing that period, unprecedented period at that time. Okay, health for for you all. Thank you very much.
Hello everyone. Welcome to this study presentation on a blockchain approach for social responsibility. This study was accomplished by me, Augusto Bedin, Dr. Miriam Capretz, Dr. Vander Queiroz, all from Western University, and Syed Mir from London Hydro Company. So in order to understand what this presentation is composed of, I've outlined the topics of discussion and given a little overview on what they are about. First, we address social responsibility, going over its definition and why should we care about it. Next, I'll talk about what blockchain is without diving too deep on it, and I'll give you guys a little background on it as well. With that, we glance over the chosen framework to accomplish the results of this study, followed by its application in a real-world scenario. Finally, I'll mention some final thoughts on it and wrap it up. So to start things off, it's a good idea to define what social responsibility is, business-wise. In that setting, a study defines social responsibility as the ability of a company to focus on issues beyond profitability, extending further than its economic frontiers to touch on ethical, legal, and philanthropic matters. Well, companies undeniably focuses on getting profit from its operations. That's the normal thing to do. But more socially responsible companies are willing to compromise a percentage of its profits in order to make more social and environmentally aware decisions towards its productions, whether that be a service or a product. That same study states that 49% of customers are inclined to select a more socially responsible company over its less socially aware competitors. That means that customers are willing to choose companies that share the same values as them, and that a good percentage are willing to pay a premium for that, making social responsibility a strong incentive for companies to not only keep their clientele, but to increase it as well. So blockchain is it's common considered to be a finance-oriented technology because of its inherent traits of security and integrity in handling data. It's prominent in highly regarded success cases like Bitcoin and Ethereum are both supporting proof that blockchain can yield impressive outcomes when and if properly used. Well, blockchain can very well provide in various scenarios other than financial related ones. Truthfully, any circumstance that would require a high level of trust among parties or even a third party intermediate to validate the interaction can benefit from blockchain's trusted environment. Owing to this, blockchain found its way into energy, government, IoT, medical industries, and various other sectors, demonstrated its flexibility in numerous scenarios. But one of the relatively unexplored paths of blockchain is that of social responsibility, which was one of the motivations behind this study. So going over what blockchain is now, we can move on to the more technical aspects of it. Blockchain technology consists of recording the exchange of information within a network where every user holds a ledger with the records of every movement of every piece of information. This information is exchanged in the form of authorized transactions validated by the network users. So what it is a chain of blocks where each block has all the transactions that took place within the network. The way information is stored in the blockchain is that each block contains an identifier hash pointing to the previous block and a package of transactions that have taken place in the network. So every block of information is final and can't be tampered with, as the identifying hash is a direct consequence of every other hash that's been assigned so far, meaning that if one block were to be tampered with, the whole chain would then be compromised. So this is what a blockchain network would look like. Each node displayed here would have a copy of the network's ledger containing the blockchain and all the information in it. Each node here is a user that has access to the same information as all of the other users in the network. So we can list here a few advantages of blockchain, and they are that blockchain networks allow for a more welcoming integration for newcomers than regular non-peer-to-peer applications, since integrity and security technicalities are not a matter of contention. which is excellent for business-to-business interactions, where setup time can be kept to a minimum and business can focus their time on the important stuff. A new node in the blockchain network will be granted a ledger of copy with all the information available in the network. So this alone provides a trust bond with the newcomer and the current network's user body. Transactions within the network must be authorized through a consensus reached by the majority of users. So whenever a user tries to perform an action within the network, it needs to be validated by the majority of users to ensure its authenticity and integrity. Because every piece of information inside the blocks has been previously approved by the majority of users, the data is regarded as legitimate and trustworthy. Additionally, computational procedures can be triggered when performing transactions on the blockchain through smart contracts. Smart contracts are what we could call like the logic behind the network. So this image shows how smart contracts are triggered and executed on a valid transaction within the blockchain. The transaction gets requested and that triggers the execution of a smart contract, which is basically a piece of code with steps that said transaction will execute if approved. The smart contract is executed when the transaction is approved, and then the transaction gets committed to the blockchain, meaning that it gets placed into a package that then gets inserted into a block that will eventually be added to the blockchain. Now, there are two main types of blockchain. We have public or permissionless blockchains, which are the most common type. It is the type of blockchain that Bitcoin and Ethereum are built on. On blockchains of such large scale, it becomes impracticable time-wise to reach consensus among the majority of its users to validate transactions. Because of that, it operates on a proof of work basis, or mining, as it is more commonly called, which translates to for users to perform transactions, they need to spend enough computational effort to prove that their transaction is legit. Anonymity plays a big role on public blockchain, so that's why strong safety measures such as complex mining need to be taken in order to promote trust among its anonymous users. And now here's what a public or a permissionless network is composed of. All of its users or nodes are anonymous, and if the network is large enough, they'll have to solve complex problems that will require a lot of computational effort to generate a valid hash that will validate the attempted transaction in order to put it in a new block. Now, on the other end of the spectrum, we have private permission blockchains, which was the type of blockchain used in this study. In a permission blockchain, users must be granted access through the emission of an identity issued by a trusted entity, which is a node with the authority to provide identity certificates for newcomers. This allows for a more controlled access to the information within the network, as well as how that information is used by the users. Because of that, it is more business focused and business logic can be more easily implemented on it. Like interactions between partners can be monitored so all the users are aware of what goes on their network. Additionally, sensitive data is readily available once newcomers are allowed in the blockchain network. Well, businesses are often reluctant to cooperate because disclosing operational information can be seen as a threat rather than an opportunity for growth. But here, it in a safe and controlled environment where all the participants are trusted and previously approved, it is quite harmless to share their data. And on top of everything aforementioned, no proof of work or mining is required differently than public blockchains. The identity certifies that a user is authorized to perform transactions in the network. So when it comes to permission blockchain, this is what it would look like. They're usually much smaller in scale, given the fact that only trusted participants are allowed in. Every node or user here is identifiable to every other user in the network, and consensus must be reached through majority approval. Again, usually because these networks don't reach huge proportions, and time-wise it's still viable to perform majority consensus. Now, with that in mind, it's time to talk about Hyperledger Fabric. It is a permission blockchain framework made possible by the Linux Foundation, and it was the framework of choice used to implement this study's blockchain network, which made use of its business-focused features such as selecting which parties to interact through with chain code, which are smart contracts in the Hyperledger Fabric context. So in this image, we can see here a sample Fabric network composed of different businesses. All of them were allowed in through an authority within the network. For the sake of this presentation, we'll say that Organization A here is the leading authority. So each of them have their certificate of identity issued by Organization A and their own copy of the network's ledger, as well as the smart contracts that can be triggered. Fabric easily allows participants in and out, so newcomers can have peace of mind taking the longest chain of blocks as the truth of what happened in the network prior to their entrance or while they're gone, if that was the case. So to better illustrate the usage of a permissioned blockchain, a use case scenario is in order. In this study scenario, a local energy provider wants to avoid energy disconnections. In order to do so, they want to speed the process of having assistance programs assist clients who are unable to pay their electricity bills. Clients, for some reason or another, might run into trouble meeting their bills. Service disconnection is a last resort that's dreaded both by clients and the energy provider itself, as it is a rather extreme measure to be taken, and it's a lot of hassle to come back from that. Here we analyze how bringing together clients, the energy providing company, and assistance programs together in a blockchain network would be beneficial to all of them. So in this case, the blockchain would be composed of the energy provider's clients, the energy provider itself, and assistance programs able to provide aid. In Ontario, the location where this study was made, there are several assistance programs able to provide aid with electricity bills based on a person's profile. So they could all be included in the same network. So with clients' information readily available in the network, assistance programs would be matched to them based on their information through chain code or smart contracts. The information required for those usually consists of the number of people in the household and the total household income. So once a client is matched with its eligible assistance programs, he or she would then be able to request assistance and let the organizations communicate between themselves to figure out the assistance details, making help that much more accessible. So what we have here is a comparison between the current scenario, which is A, and the blockchain network improved scenario, B, in terms of service delivery. In the current situation, scenario a client whose bills are overdue will receive a warning letter. For that client to receive assistance, it needs to take that letter to an assistance program he or she is eligible for and request assistance based on its current situation. From there, the client needs to wait for the assistance program to approve its request and then take that response to the local energy provider. Once again, for it to process the assistance program's response and finally lift the warning on that client's bills or provide a reconnection if needed be. That process can take days or weeks depending on the response wait times, while requiring the client to transit through multiple organizations with its request. On scenario B, though, we have a client requesting assistance from an organization that participates in a permissioned blockchain with many assistance programs. Here, the organizations have access to the client's information in the blockchain where both of them participate, allowing the request response times to be much shorter, while also not requiring any additional effort from the client, since information is readily accessible on the network as soon as it is available. As a disclaimer, it is vital to note that providing means for a client to keep their bills is absolutely not an energy provider's responsibility, as traditionally their focus would be just to get paid for providing electricity to their customers. This relies solely on being the socially responsible thing to do. So, one of these paper's goals is to foster the idea of using blockchain as a means to securely unveil information with other companies to mature and progress together for the sake of social responsibility. In the case we analyzed, clients' information would be disclosed among partners companies to provide better and quicker services to the community, speeding up the assistance grant process in order to reduce electrical disconnections to nearly, if not zero. We make the social responsibility case by providing just one example of how companies can go out of their way to improve customer satisfaction while simultaneously strengthening relationships with its business partners. Additionally, we contemplate the idea of bringing together multiple companies to provide clients a single service request platform. With blockchain, it's not difficult to imagine a scenario where a person that just moved to a new city would be able to access a single platform and request every required service for its new home, like hydro, gas, cable, phone, internet, etc. And well, a blockchain network could be set up with all the basic service providers so that they would all have access to the customers in need of their services. It is a quite ambitious but very plausible next step for in terms of future work for this study. Well, all in all, this concludes this presentation for a blockchain approach for social responsibility, and I honestly hope it was an enjoyable ride. Feel free to email me with any questions about it, or if you'd like to talk about what I just presented, I am obviously all ears. Thank you.
Hello everyone, my name is Felipe and I'm here today to present to you a method for clustering and predicting stock price by using neural networks. It was written by me, by Thiago, and by Adilson. So let's start. First of all, it's important to understand what the stock market is. So when someone has a large company, it can sell some little pieces of that company to shareholders. So these shareholders buy some shares of that company and become their partners. So it's important to note that here in this paper, we are going to use the name stocks all the time in order to correspond to that tiny fraction of the company. It's also called shares or another names, but here in this paper, we often use the term stocks. So stocks, the stock market, is based on the movement when some buyers and some sellers are trying to combine their prices to sell that small fraction of the company. So if I want to buy something for $10 and someone wants to sell it for $11, we can agree on 10 and 50. So $10.50. So all the movement in the stock market is based on that psychological effect. So when the price combine, when someone wants to sell it for the same price that someone wants to buy it, that movement is done. So it's important to note that. And also we are going to use artificial intelligence in this paper. So artificial intelligence was proposed a long time ago, and we are hearing a lot about it. There are some methods using machine learning in our daily lives, in social networks, in websites that we use, Amazon, Netflix, Facebook, all of them are using artificial intelligence. And fraction, any specific method of artificial intelligence, of AI, it's called deep learning. It uses neural networks that try to emulate the human brain in order to compute, to use a lot more computational code, to use a lot more of computational resources in this case, to process a large amount of data. So it's basically a machine learning algorithm, but much more deep. That's why it's called deep learning. So there are several layers of knowledge, and these layers try to emulate the human brain. And trying to do that, the computational cost is very high, but the results are really good. The predictions made by algorithms using neural networks normally are high. The amount of error is smaller and the prediction are better. So we are going to use that in order to cluster some stocks. So what is the process of clustering? The process of combining, of grouping some stocks. We are going to use some artificial intelligence algorithms to do that based on some similarities that we are going to talk, but it's important to understand that an artificial intelligence algorithm will be used in order to group similar stocks. And also we are going to predict some prices. So several algorithms can be used in order to predict some values, and we are going to use all of that in the range of artificial intelligence in order to achieve our goal. That is, our problem is try to check if it is possible to forecast the movement of a group of similar stocks. Why are we going to do that? Because we know that it's possible to predict the movement of just one stock, but is it possible to predict the movement of a group of similar stocks? And most of all, a group that was formed by artificial intelligence algorithms. So is it possible to forecast that movement? Is it possible to do that? We are going to answer that question in the next slides. As we are going to present a method, it's important to understand that it can be used in several other knowledge areas or stocks. So the first part of our process is to organize our data, to extract it and organize it. Second part, we're going to cluster these stocks. So after gathering all the information, we're going to cluster it based on some similarities. And in order to do that, we have used the k-means algorithm. I'm going to explain it to you. And then, once we have clustered the stocks, we are going to predict their movement. In order to do that, we are going to use neural networks, and more specifically, we are going to use recurrent neural networks, RNNs. But there is one problem called vanishing gradient problem that we are going to use long short-term memory in order to solve that. And later, we are going to present the results. So let's move on. In the first part, the dataset containing all the stocks, all their price, their dates, and their values was downloaded from Kaggle website. The link is in the paper description, so you can check it there. And we have used just two exchanges, New York Stock Exchange and the Nasdaq. And we have used just the period of January 2018 until March 2018. It's important to note that you have extracted that files, and each exchange contains a number of files, a number of companies that have their shares on that specific exchange. So we have selected just those that have been negotiated in this period of time. So these are the numbers, 3,000, around 3,000 for each one, and the number of extracted files, the number of companies that have their shares bought or sold on this period are this one, 1,000 for New York Exchange and 800 for Nasdaq. And the file is basically this one on the right side, containing the date, the open, high, low, and close values, and the volume negotiated on that given day. In order to cluster a group of stocks, we need to calculate the return for a specific period. In this case, we are going to use the period of 1 day interval. So we are going to use the value of that stock in the next day and calculate the logarithm value of that day based on the previous one. So we are going to use logarithm values in order to facilitate our calculations. And after calculating the return for any specific period of time, we are going to use Pearson's correlation coefficient. So this is the metric, this is the formula, and it's important to note that the results go from -1 to 1, and the signal indicates the direction of the relationship. So we are going to use two companies, and in this case we have compared all of them together. So it was a combination of all the networks, of all the exchanges, all the stocks, all the companies in this dataset to check which one is similar to other one. We have used that formula to do that, the Pearson's correlation coefficient. And later, we have used the k-means algorithms. It was used in several studies, and all of these studies have used it in order to cluster stocks. And it was used once it outperforms other methods in terms of cluster compactness. So we want a compact cluster, we want stocks that are really similar, so we're going to use k-means in order to do that. Other important fact, now entering the area of artificial intelligence, is that we are going to use recurrent neural networks. They are commonly used in text translation, for example. So you try to predict a value based on several past values. So we use all the knowledge, the past knowledge, in order to predict that one, the next one. So if you are going to translate a text, or if you are going to try to guess the next word in a text, you need to use the whole sentence, the whole past words in that sentence. So recurrent neural networks are used in order to do that. And in this case, how we're going to forecast the price for a given date, it's important to analyze it based on all the past days. So we're going to use recurrent neural networks. But there is a problem. Trying to predict a close value, trying to predict a small value, it's easier than trying to predict a big value. For example, it's try to predict the next word in a sentence, then the next word in a big text. So if you're going to predict the 11th day, it's easier than to predict the 100th day. The 3 months after, it's difficult than the 3rd day, for example. That's why important information is faded away. That happens because of that. So that's a problem. The vanishing gradient problem states that those important information that are in the previous period of time are getting lost in the process. So there is a solution for that, and it's called long short-term memory, and basically use some gates which allows for some weight adjustment. So if that specific information is important, it will go through in the network, it will go through in the process. If it isn't so important, if that weight is not so heavy, if the information is not so relevant, it will not be passed on. Important information are going to be passed on, and the algorithm will keep learning important information, but those that are not so relevant are not going to be passed through the network. So okay, now that we understand all that we have done, all the methods that we have used, we are going to present you some results of that. First of all, the Pearson's correlation coefficient. So we have plotted two matrices and containing all the values. So a greater value attests that those two stocks are similar, and a smaller value closer to 0, they are not similar. So we have all these giant matrices containing almost 1,000 values, and we have run the algorithm in order to group the stocks based on that. But one of the problems of clustering stocks or clustering or using k-means is the number of groups that we are going to have. So in order to get the correct number of groups, the correct number of clusters that we must use, we have used this method called the elbow method. And basically we plot a graph containing the error and the number of clusters. So the error is very, very high when we have just one cluster, for example, and it goes down when we increase the number of clusters. So in that case, we can get the closest value near the elbow of the graph. In this case, we can check that the graph starts to reduce the errors. The difference in the error is not so great. It's not that big after 20 groups. So we have chosen for both stocks, for both exchanges, the number of 20 groups, 20 clusters. So before that part, we had almost 1000 files, and now we have just 20 groups. So similar stocks were grouped in these groups, in these 20 groups. So instead of forecasting 804 stocks, for example, we have just to forecast 20 stocks, 20 movements. So it makes it easier for someone who is trying to predict some values to use this method in order to reduce computational costs. And later, based on that groups, we have tried to predict their prices. So the group data was used as an input, and each group was trained and tested separately. So the algorithm was used, each group of that previous step was used as an input for the algorithms. And for all of them, 80% was used for training and 20% was used for test. In that case, we have really, really small errors in our predictions. So we can check that these are just some results. We have the whole table, the whole spreadsheet in the paper, but it's just to show that the error was very small. And now we can see the results from New York Stock Exchange. The 3 images on the top are the worst results, and the 3 images in the bottom are the best results. We can check that the movement, basically the algorithm is getting the movement right. So when the blue line, that is the prediction, goes up, also the actual value, that it's the orange line, also goes up. So the algorithm is getting the values right. But sometimes when something happens in the beginning of the process, it lost all the prices, all the correlation, we can state that. But in some cases, like the 3 other in the bottom, the values are very similar, the predictions are really good, and it's really close to the actual values. The same thing occurs in the Nasdaq exchange. We can check that the predictions and the actual values are really close to each other, and we have the same problem when the predictions go wrong. The algorithms understand that the movement will go up or high, but as it got lost in the beginning of the process, it goes wrong through the whole period of time. Based on that result, using now this graph, we can, for example, understand that trying to predict the movement and not the price would be a better solution for our problem. So predict if that day goes high, the stock goes up or goes down, is better than trying to predict the movement, trying to predict the exact value. But we have also got excellent results on trying to predict the values. In conclusion, our results were really good. We have potential results. The predictions were good. The error was really small. And it's important to note that this type of work reduces the computational cost of someone who is managing some large fund, for example, someone who is trying to predict a large number of stock's value, and we can use it in order to reduce computational cost. That's an important result. Also, the error increases through time. So if we get something wrong in the beginning of the process, it increases through time. So we also have to analyze that. And as I was saying before, as I was explaining before, the accuracy could be improved if the direction of the market was used as a future. So if we were trying to predict if the market will go up or down, it would be easier than trying to predict the exact price of that stock. So that's our work. I hope that you have liked it, and feel free to contact us in our emails. Thank you. Have a good day. Hello everyone, my name is Felipe, and I'm here today to present to you a characterization of women's scientific participation in Brazil. It was written by Monique, Thiago, and me. So let's start. First of all, there are several studies that try to understand how science has evolved and how scientific collaboration occur, and they use the scientific production in order to do that. And among them, there is the importance of gender in these studies, and gender tries to identify how the identity and representation of men and women in society. And among these studies, there is a specific field and a specific type of study called study of women. And this group of study, tries to understand how women and how is their correlation, their varied relations with science. So this type of study tries to profile the trajectory and performance of women in their careers. So they try to analyze and identify how is the trajectory of women in their careers. So it's important in order to study the scientific collaboration or the science in this field. It's important to use some source of data, and normally the data is present in several repositories, but here in Brazil we have the Lattes platform, which contains the curriculum, research groups, and information about institutions and places to study. So it provides high quality information because it's an standardized repository. So basically every researcher in Brazil, usually they have their curriculum registered in the Lattes data platform, since it is used in order to provide scholarships and government policies. There are several institutions that use the Lattes platform as their main source of data. So it is a large data repository, and we can use it in order to understand the evolution of science production and even scientific collaboration. So there are some problems when we are analyzing, when we are using a large data repository, and one of the main characteristics of them is that they don't have any standardized, they don't have a standard, they don't have information present in the same format. And another problem is that it is a complex task because there are several repositories and there is a large amount of data, and it's difficult to understand all of this information. But we can use bibliometrics and they have a lot of techniques. This field of research has a lot of techniques, that help us in the process of quantifying written communication. There are some statistical methods and some indicators that helps us to understand the evolution of scientific research. So, our objective is to analyze the scientific and technological participation of PhDs and investigate how their research has been carried out and how their academic trajectory has evolved over the years, using bibliometric analysis carried out on curricular data available on the LATS platform. So we are going to understand how PhDs, how their relationship, how their academic trajectory using the LATS platform as our main source of data. Okay, so our methodology. It's important to define the study population. So we have chosen to work just with PhDs because they are responsible for 75% of the journal publishing, papers published in journal, and 65% of papers published in conferences. And also they have a most recent updated data of their curriculum. So they produce more and they update their curriculums more. It makes them the perfect population for our study. And according to that, we have an inclusion criteria that is PhDs who have their curriculum registered in the LATS platform and their gender is female. Also, we have an exclusion criteria that are curriculums with incomplete data according to our analysis. And in order to do that, in order to use the LATS data, in order to use this repository, we have used a framework called LATS Data Explorer, and it helps us to gather all this information, select it, and train and obtain all this data, treat it, and this framework helps a lot. And the data used in this study was collected in October 2019, and over more than 6 million curriculums were collected. After the first selection, containing just the PhDs, this data corresponds to 5% of that first one, and it's 300,000 PhDs in the LATS data platform. So, among all those researchers, we have first selected just the PhDs in October 2019. And then we can follow on to our methodology steps. And from that 300,000 curriculums, we have selected the gender. It's important to explain that the curriculum itself doesn't contain the information about the personal information about sex or other type of personal information. So it was necessary to use the Directory of Research Groups in Brazil. There are some groups of research, and in those groups you can select the gender. So based on that, based on the groups, the research groups, we have used that information contained in the group in order to know the gender of the curriculum, of the person who owns the curriculum. So each ID of the director of groups was stored, and as the image shows, the first ID is female and second ID is male. So we have compared the IDs of the director of research groups against the curriculums registered in the platform. So based on that, we have selected 100,000 curriculums of gender female. So from the whole population, we had 6 million, and now we have 100,000 female PhD curriculums. So after selecting this specific information, we have prepared the data. So among those informations contained in the platform, we have selected some of them: orientations, productions, their major areas of research, academic formations, and their publications. And all this information was selected from the curriculums that are stored in the format XML. And the visualization model was done in order to provide some useful information. So all of this data was exported using graphics and tables that we are going to show here. So first of all, understanding our partial results, we can analyze the completed orientations and ongoing orientations. It's important to note that in the completed orientations, we have analyzing the masters, the PhDs, and the postdoctorate orientations, it corresponds to 46% of the completed orientations. And among the ongoing orientations, it corresponds to 18%. So what we can understand here is that PhDs tend to advise more undergraduate students and less graduate students in the beginning of their career. But over the years, as they complete their PhDs, the number of undergraduate orientations decreases and the graduate orientations increase. So, as the completed orientations are analyzed using the whole trajectory of that researcher, the orientations made on a lower level represent more in this process. So the lower level, as undergrad and specialization, scientific research, represent more of the orientations of a researcher. Because of that, because in the beginning of their studies, they tend to advise more in that lower phase. Another result that we can analyze, another data that it's present in the LATS data platform, it's related to productions per year. So there are several information presented on this graph. First of all, we can check that from the beginning of the LATS data platform and the first productions that were posted on the platform, from the 60s to 80s, the production seems very similar and it remained constant. And there is an hypothesis for that, because the LATS just became a standard format for research in Brazil after 1999. So after that the researchers started posting their information in the platform. So there is a hypothesis that that's because in this period there aren't so many publications, and also there weren't that many PhDs here in Brazil in that period. So in the beginning of the 80s, there is an increase in all types of productions among the years, and with regard to article in journals, it showed a significant growth until 2013, and it remained constant until 2017. Also, the production of articles in proceeding in congresses has had a considerable increase until 2011, and after that year it has fallen more than 50% until 2018. And there are also some hypotheses for that, because in 2011 the CAPS, that is an organization here in Brazil, it stopped considering papers published in conference for the evaluation of the programs. So if you have a program, for example, computer science program in your university, this institution is not from 2011, it stopped considering articles published in conferences in order to evaluate the programs. So because of that, there is this hypothesis that because of that, the productions of papers in conference has fallen that much. So on that period, the publications in journals were considered more relevant for the evaluation of the programs. There are also some results related to conference papers and papers published in journals based on the areas of activity and based on the production per capita. So we can analyze here that based on the areas of activity, the health science produce more, but considering the per capita, agrarian science produce more considering conference papers. Also, it's important to note here that engineering, considering the activity, produce less than the other areas, but it's the last but one, considering their activity, but considering their production per capita, it's the third one. So it shows us that even they have less PhDs, they produce a lot of papers and a lot of productions in different areas. Also, we have the information about the academic record, and you can select when have you graduated, when you have initiated your studies and when you have graduated. And we can check here that the average time for completing a master's degree is around 3 years, and the average time for completing a doctor's degree is 5 years. There are some cases here, and the average is always greater than 3 years for master's degrees. And it's important to note that there are some records, around 100 records, that shows the academic training for master's degree, for example, from 11 until 23 years. So there are some records that increase that average a lot. But it's important to note that the median, it's the same for all areas in the knowledge, all knowledge areas. Also, PhD, it's a chance to go deeper on your studies, to understand the concept more deeper, to analyze a lot of concepts, and we can try to understand how it's the evolution of the complexion of the academic training. So if someone studies in the humanity science for their masters, have they changed it after for their PhD? So in this graph, we're trying to analyze if researchers tend to change their area from the masters until their PhD. If they have done the masters in one area and they have changed that area for their PhD. So analyzing that, the area normally do not change, And the number of researchers in each area has remained the same. Also, the most relevant, the most areas where the PhDs were trained had changed between exact and earth science, humanity science, biological science, and health science. So there are several contributions in this article. We have presented a view of women's participation in a temporal way in this study. Also, we have understand how it's important to analyze the scientific production by PhDs, how it's important to have a scientific data repository that it's the standard for the whole science in Brazil. We have also showed the importance of productions of PhDs based on their areas of activity. And this type of study is relevant and can be a source of inspiration for government policies and programs that encourage the change and promote equal participation for women and men in science. So it was a pleasure having you here today. If you have any doubt, feel free to contact us in our email. And thank you, everybody. Have a great day.
Hi, my name is Enrique Muriel Torrado. I am assistant professor at the Federal University of Santa Catarina in Brazil. And along with my colleague, Daniele Borges Pereira, we wrote this paper, Correlations between the concepts of disinformation and the Fogg Behavior Model. We are very glad to have the opportunity of sharing this work in this conference. Nowadays, it's pretty easy to create, to share information, or pictures, or news without any verification. Apparently, in our information society, we use social media exposing and manifesting ourselves in a pretty emotional way. As researchers, we are interested in the human behavior and how we face this information in the digital context. To do that, we made an approximation to the Fogg Behavior Model, a psychological model which shows that three elements must converge at the same moment for a behavior to occur: motivation, ability, and a trigger or prompt. This model was created to understand how it is induced a certain behavior. We also know that many enterprises around the world, like Instagram, Facebook, and many application creators use it for their apps. This is one of the reasons to understand why our cell phones are so addictive. They know how to change our behavior, or at least they try to do that. So, can this model be used for disinformation or fake news? How it works? Well, here we can see two different representations of the same model. We are going to focus on the first one on our left. The use of this model characterizes the reasons that lead a person to perform such action, and for a specific human behavior to occur, it is necessary to present the three factors, having motivation, ability, and an effective trigger. The vertical axis corresponds to the motivation. In the upper part of the axis, consider high motivation, and the lower part, low motivation of an individual to perform the pre-established behavior. In the horizontal axis, we have got the ability, where the left side corresponds to low ability and the right side to high ability of an individual to execute the target behavior. In addition to the axis, there is the factor that Fogg names as triggers or a prompt, an item that is close to the star. The star represents the behavior of the target, the behavior that we desire. The presence of this factor is essential for the behavior to occur. The trigger and star can be directed anywhere, differently from the fixed axis of motivation and ability. In the case of motivation and ability, they are usually necessary for behavior to occur, but as depicted with the diagonal arrow, it emphasizes the relationship between motivation, ability, and target behavior, the star. Individuals with high skills and motivation are more likely to perform the desired behavior. As we can see in the right figure, for a behavior to happen, it is needed to cross the green line, the action line, with two elements, motivation and ability, both activated by the trigger. Well, I'm going to try to explain it in a different way. One of the things that it has to happen for us to do any behavior is that we have to have a trigger. The trigger tells us, do that now. For example, I get a phone call, my phone rings, so that is a trigger. But I am in the middle of a romantic dinner and I'm not going to answer the phone. So that's the ability. I cannot do it now. I take my phone just to see who is calling, and it is my boss. Well, right now, as you can imagine, my motivation is null, zero, absolutely nothing at all. That is the motivation. I don't want to answer. So in this example, we didn't have the three elements at once. I had a trigger, my phone was ringing, but no motivation nor ability. And the result is I don't answer the phone call, and I can keep enjoying my date. Well, if I can forget my boss, of course. Here we got the three elements. First one is motivation. Inside of motivation we got pleasure or pain, usually immediate factor. They are powerful motivators and a primitive response being able to adapt to various situations. To increase motivation, pleasure, and pain might be incorporated. Hope, fear. Anticipation of a result. Hope is the anticipation of something good happening, and fear is the anticipation of something bad happening. Social acceptance or rejection. Controlling part of our social behavior, people are motivated to do things that give them social acceptance and even more motivated to avoid being socially rejected. Ability. Well, the first one is time. If target behavior makes time and we have no time available, the behavior may not occur. Money. For people with limited financial resources or that don't want to spend money, targeted behavior that costs money may not happen. Physical effort. Behaviors that require physical effort may not be simple. Brain cycles. For the most part, we overestimate how much ordinary people want to think. If performing a target behavior leads us to think too much, it may cause the individual not to achieve the desired. Social deviance. If a behavior requires going against the norm, violating the rules of society, that behavior is no longer simple. Non-routine. Activities and behaviors that need to get out of routine or need to be learned, people may not find it simple and end up not performing the desired behavior. And the last element, triggers or prompts, we got inside three. A spark as trigger, used when a person has no motivation to perform a behavior and so a trigger that has to do with a motivational element is designed. Facilitator. Suitable for users who are highly motivated but not skilled. The facilitator triggers the behavior and at the same time makes it easier. An effective facilitator tells users that target behavior is easy to perform. That is, that it does not require a feature that he or she does not have at the moment. Signal as trigger. This type of trigger works best when people have a motivation and ability to perform the behavior. The signal is just a reminder. What did we do? It's a qualitative and exploratory research. We thought it's possible to analyze those definitions of UNESCO, European Commission, Oxford Dictionary, World Economic Forum, and Reuters, with elements of the Fogg model in mind. That was our idea. So what we did, we took the definitions, for example, disinformation, misinformation, misleading information, and fake news of UNESCO. Disinformation is information that is false, proposital created to harm a person, a social group, or an organization or country. Misinformation is information that is false, but it's not intended to cause harm. Misleading information, reality-based information used to harm a person, social group, organization, or country. Fake news is intentionally lying content that is launched on a fake website or social networks to harm a person or group. UNESCO prefers to call them disinformation campaigns, for example. So what did we do? We took these definitions and we tried to see the elements inside of the Fogg model. For the first one, disinformation, we have motivation, pleasure and pain, and the trigger is a spark. For misinformation, we have the social acceptance or rejection. For the last one, we have ability, social deviance. The next definition that we got was the European Commission, disinformation. And we did exactly the same. We tried to identify the motivation, is a social acceptance or rejection, the ability, brain cycles, time, money, and social deviance. And the last one, the trigger, is the facilitator. We also checked the Oxford dictionaries to see what they say about the fake news, false reports of events, written and read on websites. Many of us seem unable to distinguish fake news from the verified source. Fake news will create this significant public confusion about current events. Misinformation as the act of keeping wrong information about something, the wrong information that is given, a campaign of misinformation, actions, attitudes based on misinformation, post-truth, relating to circumstances in which people respond more to feelings and belief than to facts. In this era, the post-truth politics, it's easy to cherry-pick data and reach any conclusion we like. So again, we identify the ability of brain cycles and social deviance in fake news, for misinformation, social deviance, for post-truth motivation, pleasure, pain, and hope, fear, and the trigger, spark. We take again the last one, fake news for World Economic Forum, can be as slippery to define as it is to pin down. Stories might be factually inaccurate and deliberately published to underscore a certain viewpoint or drive lots of visitors to a website, or they could be partially true but exaggerated, not fully fact-checked before publication. What do we find here? Pleasure, pain, and social acceptance, the time, facilitator, and signal. So the last one is Reuters. Fake news is only partly about narrowly defined fabricated news, and very more about broader discontent with information landscape, including media, politicians, as well as companies and platforms. So here we identify pleasure and pain. We identify as trigger spark. This table is just a resume. We can see in the table the main element and the amount of times they appear in the definitions. So the most common elements are for motivation, pleasure, pain, for ability, social deviance, and for the triggers, the spark. The use of this model characterizes the reason that lead a person to perform such action. So the first element, powerful motivators like pleasure, pain, looking for a primitive and a fast response. As the second element, we found that the kind of information goes against the norm and at the same time might cause damage to our society. This is the ability, right? Class element. The definitions use the spark as trigger. So we don't need to be ready to share this information, to be motivated. The trigger will be related with the motivational element design. That's the pleasure and pain. Some final considerations. Fake news and disinformation are created with a purpose, mainly manipulation. Manipulation of the population. The analysis show up that the definitions have some correlations with the elements of the Fogg model, a model used by many enterprises to manipulate our behavior. To learn how false information, disinformation, fake news are created, formulated, and why do we share them? In other words, how this information influences the human behavior. It's fundamental to stop it. In future works, we will apply this model to some examples of disinformation, like politician tweets, to see in practice how it works. Well, now you have any consideration, you can send us an email, please, or you can contact us in Twitter too. And I would like to say thank you very much.
Hello everyone, my name is Felipe. I'm here today to present to you a strategy for contributors' recommendation in scientific data repositories. It was written by me, by Monique, and by Thiago. So let's start. First of all, it's important to understand what networks are. So we can model basically everything as a network, our friends, our friendship between them, our family, our network coverage area, airports. Many things in our daily life can be modeled as networks. And it's important to understand how a network is formed. So we have two important elements. We have nodes and we have edges, or links. So a node, it's an object that we will create a connection, that will have a connection between them. So in a friendship network, the people would be nodes and the friendship would be edges or links. In an airport situation, the airports, the physical places where the airports are, would be the nodes, and the trips made by planes would be the edges. So if there is one trip, if some company makes a trip between airport V2 and V4, there will be an edge, a connection between them. So networks are used in social networks, for example, where we have our friends, we have our interests, we have a friendship between friends, between people in the network. And there is a problem. Someone thought that if we can understand what drives the evolution of the network, we can try to predict how the network would be in the future. So this was called the link prediction problem, and I'm going to explain to you what it is. Based on the link prediction problem, as we understand now what networks are, we can also try to think about the evolution of the network. So how will it evolve in future instances, in future moments of time? In this case here, for example, there is a connection between the nodes v2 and v4 and v1 and v3. In some period of time, in the moment t here, a connection was formed between nodes v1 and v2, and in a later moment, a connection between v1 and v4 was also formed. Based on that, we can try to understand how will this network evolve. So the goal of the link prediction problem is try to understand what are the factors that contribute to the evolution of the network. What are the factors that make two nodes create a connection between them? So that is our problem, and we are going to use co-authorship or co-authoring networks in this paper. So as we have a network of friends, a friendship networks, a social network, we can also have a network of people who have written papers together, who have published papers together. So this is a co-authorship network, a co-authoring network. All of us here in this conference today, we have written some papers and probably with some co-authors. So we all of we here, we are part of a co-authoring network. So I have written this paper with Monique and Thiago, so I have edges, I have links between me and them. All of you, I hope that you have co-authors also, and you have your own network. And this network is being performed, is being created between all of the researchers. So it's possible, for example, to create a network of all the researchers in this conference. Okay, but we need some place to extract the data in order to perform a link prediction in co-authoring networks. And this place was chosen. It's called the LATS platform. It's a platform, a Brazilian platform, that contains more than 6 million researchers' curriculum registered. So it's an important database. It's one of the most important in the whole world, because in Brazil, most of the projects and scholarships, and in order to work as a professor, as a scientist, you probably must have your curriculum registered in the LATS platform. So that's why we have basically all of the researchers in Brazil have their curriculum registered in the LATS platform. So it's an important data set, an important place where we can gather all this data in order to perform this work. And based on that, our goal is the prediction of links in co-authoring networks formed by the data of PhDs with curriculum registered in the LATS platform in the area of information science. So we took all the LATS platform, all the curriculums, and we have chosen to perform this operation just in the area of information science. So I will explain to you all the numbers, but our goal here is try to predict how will the information science PhDs network evolve in the future. In order to do that, we must follow some methodology. We need to extract the data from the LATS platform. Then we need to create our collaboration network or our co-authoring network. Using this network, we can better understand it and try to gather some attributes that will help us to predict the future of this network. And with these attributes, we can create our data set. This data set will be used as an input in the prediction algorithms, and then we will evaluate all the process that we have done. First of all, in the extraction part, the latest data explorer framework was used. It's a tool that helps us to extract the curriculum registered in the LATS platform. The LATS platform is maintained by this organization called CNPq, and we need to access this website first, and the curriculums are extracted from there. We can select the curricula that were extracted. In this case, we selected the curriculum in the area of information science, just the PhDs, because everyone, for example, an undergrad student must have his profile, his curriculum registered in the LATS platform, but in this case we are using just PhDs because they are more relevant to the data set. They produce more, they have more connections, and they are responsible for most of the scientific papers published in the dataset. That's why we are just using the PhDs. And based on this extraction, we can also analyze keywords, the most important keywords of the curriculums. For example, what are they searching, what are the area, what are their projects. Also, we can calculate some metrics. And one important step in this process is the collaboration identification. So each curriculum has its own ID, each person has its own ID in this dataset, in this repository, and we can check if that person, that author, has a paper written with that another author. So ID1 is compared with ID2, and a connection between them is formed in this process. Based on that, in this collaboration identification, we can use a method to create our co-authorship network. This image shows the collaboration network of all the LATS platform in 2015, using all the knowledge areas, and it's interesting to see how the network is connected. We have a giant component in the center, and it's also interesting to check how areas correlate between them. In this case, we are just using the information science network that I will show to you in a moment. In the next step, we need to define the attributes that we will use in the prediction algorithm. These are the attributes that we have chosen. It's important to note that there are two types of attributes: the attributes related to the network and the attributes related to the domain knowledge. Domain knowledge would be where the researcher has studied, the conference that he attends, where he published, the journals. And the attributes related to the network are topological attributes, for example, number of neighbors, for example, the number of friends that two authors have in common. The number, if we are going to translate it to social networks, would be the number of friends in common. So we have used that. It's one of the most important attributes. We also have the Jaccard coefficient that measures the probability that authors have and a third author in common. We have several type of metrics that we're using in the literature to try to predict these links. So we have Adam Kadar, resource allocation, preferential attachment, And two important ones are the shortest path and papers written together. So the shortest path, it's the minimum path between two nodes, the distance between the nodes, and also the papers written together. So if two people have written a paper in the last few years, if they have written 10 papers together, the probability that they will write a paper in the future is greater. So these are the attributes used in our paper, and later we can create our data set. So we have split the time into three data frames. The first network between the 1960 until 2000. The network 2 or the network B is from by 2001 until 2010, and the later one is 2011 and 2018. We can also check how the number of nodes is the same, so we are using the same number of nodes in the latest network, and the number of edges grows with time. So in the beginning we have just a few numbers of paper written together, and later we have 30 times that. It's important to understand that the network grows through time. It makes easy to understand what happened, how the evolution of the network goes. So this also explains our goal. If we have the period 1 and period 2, what will happen in the period 3? Also, this problem can be used in several other areas of knowledge, for example, diseases and how connection between people occur. We can use this type of problem in our daily lives. One of the biggest problems with link prediction problem is called class imbalance. The number of possible links in a graph is correctly related to the number of nodes. However, the number of actual links represents only a small fraction of this number. We can understand that if we check the whole network, there are more absent edges or non-edges than real edges. In this graph, we can check that the possible number of edges is really greater than the number of actual edges. I will show to you how we deal with this, but as we are dealing with machine learning problem, if we leave the dataset like this, the algorithm will learn much more about known edges, about absent edges, about edges that don't exist than the edges that really exist, because the number of real edges, the number of edges in our data set is really small compared to the number of possible edges. So a process called undersampling was performed. Basically, we have this number of possible edges, and we have only a tiny fraction of that number of actual edges. What we do is we undersample this data set. So we choose 3000 edges. We leave it as the same number, the present edges and the missing edges. So based on that, we have a data set that is 50% actual edges with present edges and 50% with missing edges. So based on that, we can start training our algorithm. 75% of that was chosen as our training set, and 55% of that was chosen as our test set. And logistic regression was used, key nearest neighbors also, AV-Bayes, and random forest. These four algorithms were used in order to predict our links in the future. So these are some results. 4 metrics were used: accuracy, revocation, F1, and AUC. It's important to note that the AUC, that corresponds to area under the curve, is the best metric in this type of problem because it evaluates the whole process of learning, the whole process of prediction of the algorithms. I will show to you in the next slide, but it's important to understand that authors recommend using the AUC metric as a result. But also there are other metrics that, depending on our goal, we can use. But for link prediction problem, AUC is the most important. In this case, we can check that the algorithm's result was very similar. Logistic regression and naive Bayes had a poor result compared to nearest neighbors and random forest, but it's a very similar result. And why it's important to use AUC? Because of that. If we can observe here, the blue line corresponds to 50% chance of getting it right or wrong. So if we predict that a connection between node A and node B will be formed, 50% is just a mere case. It's just tossing a coin. We wouldn't be getting it enough rights. So in this type of metric, we plot this line in a 50% chance, and in the orange line is the result of the key nearest neighbors curve. So as we can check, it starts with 50, 40, and then it goes up to 70% of right. It's greater than 50, so we are doing it right. So we are predicting our future networks right. Based on that, our goal was achieved. We have predicted the information science network. This methodology is important because it can be used in different databases, including other knowledge domains. For example, diseases and other types of networks. And also, we can increase our metrics, our prediction metrics, using domain-related attributes. In this case, we have used just those attributes shown to you, but if we increase the attributes, probably the prediction metrics will be high. So it's just a preliminary result. It's just initial research. We are going to perform it in other areas and in other using more attributes. I hope you liked it, and if you have any doubt, feel free to contact us. Thank you everybody, it was a pleasure. Bye bye.
Hello, good afternoon. I'm Matthias Koekelbergs. I'm a PhD student from the Université Libre de Bruxelles and the KU Leuven, which are both in Belgium. And today I will be talking about a methodology we have developed for analyzing digitized archival collections in general, and a specific corpus from the European Union, from the European Commission that we have received. I will be using topic modeling and word embeddings to analyze this data. So very shortly, an overview of my presentation. First of all, I'll be talking about topic modeling and word embeddings, what they are, what can be done with them, and also I will underline their differences. After that, after these models, I will be talking about syntagmatic and paradigmatic axes, which is a concept in linguistics developed by Ferdinand de Saussure, and I will explain why I think this is relevant in the context of topic modeling and word embeddings. After this, I'll talk about the concrete implementation of models that I've used, and also talk in 2 words about the corpus that I'm working on. Because after this, I can come to the essence of the presentation, namely how can we use word embeddings, the output of word embeddings, to leverage the topic modeling data. And this will occur by a rearrangement of the words to make them more coherent and to find semantics in the topics. Also give some examples to make this clear. And afterwards, we'll move to a coherence evaluation, which is a quantitative evaluation of the concrete examples that I gave before. And so afterwards, I will end with a conclusion. So let's start with topic modeling. So this is a technique used for finding topics, which are a collection of keywords in documents. So as you can see here, what's the general idea? It's that we have a collection of documents. As you can see, these documents are stacked over one another. And in every document, of course, there are words, and most important words are collected together in different clusters, which are called topics. So on the left, you can see that there's, for example, a DNA topic, there's a brain topic, and there's a computer topic. And so the general idea is that for every document, we have a topic distribution, which you can see on the right. So there's the red topic, the yellow topic, and the blue topic, which to a certain extent are available or are present in the document. And so this topic distribution can be used to discuss the differences between the documents that are in your collection, and can also be used as an efficient search mechanism to find which documents are most relevant for a given topic that might be of interest to you. So another way to look at this is the so-called plate model. So again, you can see that there's different documents in the corpus, and of course in every document there's a lot of words. And so these words, every word gets its place in a topic distribution, which then can be found for every document. So every document has a topic distribution. And then for the entire corpus, for every document in the corpus, we find the mixed topic document. So that means that for every document there is a topic distribution, but also for every document, for every topic, we can see which documents are actually most relevant for this topic. And so this will then lead to topic mixture distributions and word distribution models, distributions in general. So another important idea about topic modeling is to look at exactly which words are actually important. So if you take the entire vocabulary of the English language, for example, it's distributed in a Zipfian way. So it's discussed by a linguist called George Zipf, and it's you could say the linguistic translation of a more general model, which is called the Pareto distribution, which shortly says that that 20% of the inputs accounts for 80% of the output. So it says that for language, the 20% most used words actually are found in 80% of the text. So 80% of all the words we encounter are actually only 20% of the entire language. And so these words can be divided in 3 pieces. So the first piece, left to the upper cutoff point, are so-called stop words. These are words that occur very frequently in language. So for example, conjunctions and pronouns. But usually they are considered not to be that important because semantically they do not distinguish between documents. They occur very often in every document, so they cannot be used to make a distinction between documents. On the other hand, on the right side of the lower cutoff point, there's a very long tail of words that occur not frequently. So these are words that are used in a very specific context and have very specific meaning. But in between these 2 extremes, there's so between these cutoff points, there's a list of words that have a high resolving power for topics to generate these documents. And so these words are relevant for topic modeling. But that indicates how specific topic modeling is. It's not used to model the meaning of every word in the language, but it's used in an information retrieval context, which means that it's used to find the most relevant documents in a collection, which is another way of looking at what words are important rather than just discussing the meaning of them. So a concrete example of topics can be seen here. So these are the top words for 6 topics that I've selected. So you can see directly that topic 14 is a topic that contains all these stop words which do not contribute to the meaning. Sometimes people say we should delete these stop words before doing topic modeling, but recently more studies say that maybe we should keep them so that they don't create problems during the modeling process, and then afterwards we can delete them out. And so the other topics, you can see that there's some coherence in them, but the difficulty is that topics only bring together words that have a high tendency of occurring together, but it doesn't talk about the semantics of these words. They may be in the same semantic field, but that's not necessarily the case. And so if you want to discover this, talk about semantics and concepts, then we need another technique, which is word embeddings. And so that's how we come to word embeddings. So the same for topic modeling. There's a lot of algorithms for word embedding, so there's not just one word embedding technique, but every technique has 2 architectures that can be found in every algorithm, which is the CBO, so the continuous bag of words, implementation, and skipgram. And the idea is that in both cases we take the local context of a word into account. But for CBO, we start from the context and we try to predict the words that we're interested in modeling. Whereas for skipgram, we start from a word and we try to predict the context. So research has indicated that skipgram outperforms the CBO model. So usually that one is preferred to CBO. Now, word embeddings are a kind of neural network, shallow neural network. And in the embedding layer, we can find a vectorial representation of all the words that are in the document. And these can be represented as vectors, so entities with both distance and magnitude. With distance and magnitude. So they can be represented in 2D or 3D, although they are in much higher dimension naturally because they come from very high dimensional matrices. And so there are similarity methods to find or to discuss a semantic similarity, which then are based on vector distance. The most important one is the cosine distance. So to give you an example, if you have different sentences, then if you take a context window of size 2, then we take every word and one surrounding context word. So for example, for sentence 1, W1, W2, they co-occur together. And so that means that if you look at the matrix below, that if you look at the combination of W1 and W2, we find a 1 there. And so if you do this for all the sentences and all the words that are in our corpus, then we get a very big matrix of all the contextual relationships for words. And these can be used to create word embeddings. And if we do this in this way, then we talk about word2vec, which is probably the most well-known word embedding algorithm created in 2013. And so one of the most important assets of this is that we can derive word analogies automatically from a text where no syntactic or semantic information has been given. So if you take the most important example, if you take the vector of king and we subtract the vector of man and we add the vector of woman, the vector that we find then, if we take the most similar vector to that, we will find the vector queen. And so this means that this algorithm can learn that the relationship between man and woman is the same as that between king and queen. And so that it actually learns what gender is, and that you can compute that a female king will be a queen. And so it can also be done in other cases, so such as verb tenses and country capital, or country and typical food relationships. So this shows you that we can really grasp the semantics of words and not just their co-occurrence accounts as in topic modeling. Now, there's other types of doing word embeddings, and I certainly don't want to give all the examples or all the implementations here. But another important one is are the glove embeddings. So they also start with tabulating the number of times that a word occurs in the context of another word. But instead of looking at a given context window, as in the previous example, we took a context window of 2. Here we take a probability distribution of this word in regarding the other words that we are interested in modeling. So we compare these words via a probability distribution. And as we'll see later, this gives rise to a different kind of word embedding, where the local context is not that important, and we also get a probability distribution, just as we did with topic modeling, albeit in a different way, different implementation. So here's an example that if we get very high or very low results, as in the chance of a given word k, what's the probability of k given that we have found ice, or what's the probability of k given that we have found steam? So we can see that if you take k to be the word solid, then there's a very high relationship to ice, but not to steam. And for gas, it's the opposite. It's related to steam, but not to ice, and that's why we get these very high or very low relationships. Whereas if the relation is the results are close to 1, that means that either it's related highly to both words, ice and steam in this case, or that is not related to any of them. So that's the way we should interpret these glove word embeddings. So these are both of the methods that I'm using, topic modeling and word embeddings. Now talk a bit about linguistics for a part that I think is important in interpreting both topic modeling and word embeddings. So that's the distinction between syntagmatic and paradigmatic axes, which was first described by Ferdinand de Saussure. So the idea is that for syntagmatic axis, you look horizontally at your text, and syntagmatically similar words are those that tend to occur in the same constructions. So in this case, if we start a sentence with the man, then it can be followed by cried, died, or sang. These words are syntagmatically related. And if you look paradigmatically, that means that words tend to be substitutable. So in this case, we can substitute cried by died or sang. So this doesn't mean that they are semantically similar, it just means that we can substitute them in the construction and still have a grammatically valid sentence that has a meaning. So here you can also see that for this, for the context of the cried, that we can put either man or girl there. But so for other sentences like the girl was pregnant, in this syntagmatic construction, man is not possible. That's not a syntagmatic relationship between man and being pregnant. That's not attested in the language. And so, so in this case, these are not paradigmatically related. So it's only girl and woman, for example, that can be paradigmatically related in this context, but not man or boy. So this is the idea, main idea. Now to have a look, which models did I use? Well, I used pre-trained word vectors, both from Word2Vec, which were trained on Google News corpus, and for GloVe, they were trained on Wikipedia and GigaWord. Both are 300 dimensional. There's some neurological reasons why 300 dimensions are a good space or a good dimensionality to represent semantics, but that's a different point. So these vectors can just be downloaded from the internet. And then I use the LDA topic model, which is latent data stream allocation. That's the most common implementation of topic models. I use 50 topic models, topics. That's a choice you have to make. There's some reasons for that, but I do not discuss it in this paper. And so, as I said before, I keep the stop words in the model and filter them out afterwards. So some words about the corpus. We have a corpus of the European Commission, which is about 4,000 texts, all kinds of text documentation of pacts and treaties, but also any kind of economic or political document in general, starting from 58 up till the present. And so that allows us to track the diachronic development of issues and the way they are treated in the European Union. But so the problem is that there's no metadata apart from the date for all these documents, and so they have a very big collection of text that have no structure, so we can perform keyword search on that, but we want to find more information in all this data that we have. And so that's why we came to the point that topic modeling in itself also is not really that useful. Because it only shows some similarity of words that tend to co-occur together, but we do not really have semantics in this case. We just have co-occurrence of words. And so that's why I wanted to bring together the results of topic modeling on the one hand, which talks about which words have a high tendency of co-occurring together, and bring that together with the semantic information of word embeddings, so that we can actually find concepts within topics. So find words that are semantically related in words that tend to have a high tendency of co-occurring together in this specific corpus. So that's why my idea was, if we can take the top words of every topic and then filter it or cluster it by the vectorial representation of word embeddings, that this gives us a rearrangement basically of these top keywords that has a more semantic semantic structure to it. So the way I did it, I used Gensim, and used one of their methods to just find the word that doesn't match the other words. So it finds the odd one out. So in this example of breakfast, cereal, dinner, and lunch, which is the standard example, of course cereal is found because syntagmatically it doesn't have that much relationship with the other words, and that's why it's filtered out. And so if we do that on the list of topics, and we iterate through this list, then we get a rearrangement of these terms. So an example, if we start with the original topic list, which you can see on top, then the most important word, or the most typical word of this topic list, is oil. And then we find all the other words, as you can see here, which most of them are economically in nature. And so if you use word embedding data to rearrange this topic list, starting with the most central words and then descending into less typical words. So in this case, spot was the word that is the least semantically similar to all the other words, and market is the most central word. So this means, if you can see here, all the blue words are somewhat economically relevant. So that's one concept we find in this topic. And then another one, oil, energy, and coal together are resources, natural resources. So they are another concept in this topic. And then I think the other words, country, world, commission, scheme, and spots, they do not really form a concept in and of themselves. So their distance can be measured using word embeddings to quantify, to find a threshold for every topic which distance could still be found to be semantically relevant or not. And so the interpretation is that, well, the top words, when this list is rearranged, will be the most central term. So this can be useful for indexing, that if you took the previous list, I don't think that the word oil is very relevant to index this set of words. It's also not the most central term, but market is a good word to indicate the economic terms that you find here. And so, as I've already explained, we find these semantically related clusters within these topics. In this case, it's economy and then natural resources or energy, as I've described before. So this was more the main idea and some concrete examples. But of course, we need to have some kind of quantitative evaluation of these ideas. And so I've used 3 metrics that you can see here: CV, CP, and CUCI. These are coherence measures. Topic modeling can be evaluated in many ways. Perplexity is probably the most important measure in general, but it doesn't deal with the interpretability of topics. And so when we talk about interpretability, then we need these coherence measures. So as you can see, most of them are, or two of these at least, are based on pointwise mutual information. So that's a measure, as you can see below, that takes into account what's the likelihood of finding 2 words together, normalized by the fact that, or by the assumption that they might be independent. That's the PMI, and so that occurs in the UCI score. And then a normalized variant, normalized by the entropy, that's the CV coherence measure, which you can see on top. And then CP, the one in the middle, that's a bit of a special measure where a word is associated with a set of other words that it can co-occur with. It's a set made by Wikipedia, by the Wikipedia database structure, and so this is also used as a coherence measure. But so it's not important to really understand the details of these measures for what I'm explaining. It's just that these are 3 ways of measuring the coherence of a topic, and they do it in a different way. So what I've done here is I've taken 3 topics, so topic 3, 18, and 39, and I've measured all these different coherence measures for all these 3 topics, and then I give you the results before the rearrangement, so the pure topic model results, and then after rearranging by Word2Vec vectors. And as you can see, actually in every case we get a higher score after rearrangement. And then if we compare this to glove vectors, then we can see that sometimes it's higher, but most notably in the UCI score is for topic 3 and topic 39 is lower and diverges very strongly. So in this case, we can see that glove is not that successful in making the topics more coherent, and so finding semantic clusters within these topics. So although in general glove is found to have more to have better word embeddings in industrial applications, in this case we can see that due to the inner workings of glove, it doesn't really help the topic modeling results as much as Word2Vec does. I think that's because Word2Vec focused on the local context, whereas glove then also has a kind of global context measure, just as topic modeling does, and then it's only natural that it doesn't really change the measure between these words as much as Word2Vec does. And so as a conclusion, I just give this image with you. So we can see that in purple, there's the topically related words, which are globally the same. And so they can be interpreted to be paradigmatically close. So it means that they can be exchanged in the same context. So in this case, if we start from the word electricity, which is the top word for a topic when it's rearranged, and we find the one that's most related topically, then we find fuel. But then if we look at vectors, in this case the word2vec vectors, then we find for these two top terms what are the syntagmatically most close words on a syntagmatic level, so occurring in the same construction. Then we find that almost always when we talk about electricity, we express it in megawatts in this corpus, and when we talk about fuel, we talk about gasoline. So this can help us to look at the global and the local context, bring them together, and to find semantics within the topics that we found. So that's my main conclusion, that is the method to find concepts within topics. We've also discussed that Word2vec, in this case, outperforms GloVe to perform this rearrangement. But there's still an important question, I think, that I've just selected a list of top words, usually 20 top words, to perform the rearrangement, but to me it's not really clear how I can find a good cutoff point for how many topic words to select, because for every topic, in theory, all the words of the vocabulary are there, just that most words have a very low probability, and so people have a tendency to only look at the top words, but it's not clear to look at 10 words or 20 words or 50 words. That's not really clear, so that's a point of subjectivity still in this method, whereas otherwise the finding of these concepts and finding of these topics are automatically and can be performed in any document collection available. So that's everything I wanted to talk about. Thank you for your attention.
Hello everyone, my name is Rogério Aquino, and I will represent our project, a new entity extraction model based on journalistic Brazilian Portuguese language to enhance named entity recognition. I am a master's student in the Information Science program here at the Federal University of Santa Catarina. I have a degree in computer science, and I have an MBA in business intelligence and extension in economics. I work 8 years at Softplan, a company that is a reference in Brazil in systems for public management and judicial systems. And recently, a month ago, I started to work also in the area of data science at the Social Security Institute of the State of Santa Catarina. Before looking at the results, let's look at the objectives and understand a little about structured and unstructured data, and a little about development. The purpose of our project is to create a model capable of extracting entities. These entities are names, places, and organizations, using a journalist corpus that can be found on the internet, creating an architecture that is possible to retrain the model by adding new entities, because of the already existing vocabulary. Some studies point to 60 to 65%, and the others close to 90%. But for a specific domain, like the legal one, the legal domain has a language that is not considered a contemporary or formal language. This would be a problem, if we needed increase the model in the filter. Another issue was the structure, because we needed to have a big mass of data to parse out the corpus that has information from entities to generate a single output model, since we would use more than one corpus that was in more than one format. Before understanding what unstructured data is, we have to understand what structured data is. In non-relational database, the keys value standard is usually adopted. An example is the JSON in the model above. Structured data is usually found in typical databases, whether they are relational like SQL Server, Postgres, and Oracle, or non-relational like MongoDB or Grafana. Usually, this data is organized in order to have metadata. Metadata is data about data. For example, the registration of a book inside a database, or the registration of a person in the hotel systems. In these two examples, you know the person city and age, for example, or the subject of the book and who writer is. Usually, when stored in a relational database, they are stored in several tables that have their entities like their proprietaries and the relationships between them via codes called primary keys and foreign keys. In unstructured data, they are usually recorded in bases, such as Elasticsearch, or even in liquid or binary text on our relational databases, such as images, tables, graphs, and videos, for example. Documents usually do not have much information about the content of the document in a structural way. The document may have been stored in a file that was converted to binary and was stored in a database. And when stored, the subject of the document, a data, and who wrote it were inserted. In the case above, we have a lawsuit. We have a date of creation and who filed the lawsuit. But we have no way of knowing whether the document shows the names of people, for example, or dates, or the relationships between people that appear in a text, monetary values, place, or data, for example. Therefore, it is very difficult to do some tasks that would, in theory, be simple, like values request in the lawsuit or in the location specified in the document is the same registered for the part of the lawsuit, or if certain bank information could be relevant to the lawsuit. The ideal would be to have a way to structure or at least semi-structure the data, making the unstructured data into structured data. The development phase was divided into 4 modules: corpus parsing, pre-processing, training, and version control. The first step is to transform the sections of the corpus in vectors with complete snippet, grammatical class, token, positions start and end, token size, and entity in text. After parsing, the vectors are stored in keys in a JSON file for better organization and then inserted into a Mongo database, gaining a object ID, which is a unique identifier. The training processing model is responsible for separating the parts, standardizing the input vectors to create the model. Because LSTM neural networks are used, and the vectors must have a standardized size. Dictionaries with token and index of words and tags are also generated. The training model that consists of an LSTM neural network receives the list of vectors already standardized and creates the model according to the parameters defined. Finally, the training log is saved in another collection of documents in Mongo, contain the following information: number of training and test tokens, tokens by entity, general and entity accuracy, recall, a copy of the model in binary, a list of object IDs used in training and testing, a list of parameters passed to the training model, and runtime. So it's possible to reload the model when necessary and to know exactly which criteria were used in creating it. As expected, as we increase the number of training parts of tests, it also increases accuracy and even reduced iteration by half, from 40 to 20. So, we were able to reduce the time of execution and still maintain good accuracy. In isolated accuracy, we count only tokens that are not of the O type and errors when an O token is incorrectly predicted, as they present on average 95% of the tokens in the whole database, and this end up distorting the results. Here, the accuracy per entity is shall for each training battery. Here, the accuracy per entity is shall for each training battery. It is possible to observe that even reducing the number of iterations, the accuracy remains because of the use of a large number of sections. Using 50,000 structures, it was possible for all entities to have results above 85% accuracy. The conclusion: the internal results are promising because regardless of the language and the domain of language, it was possible to create a model with results close to those found in similar articles in the English language. And the biggest challenge is the annotation, because during the research we found several corpora in Portuguese, most incorrect and incomplete, or when complete, composite of insufficient expressive data. Even with the challenge related to data and architecture, it is possible to say that the project reached to expected objective. Thank you for your attention and the opportunity.
Hello, my name is Nuno David, and these are the paper's authors. We come from Lisbon University Institute of Lisbon in Portugal. We are interested in developing distributed tools for online identification of communities in co-authorship networks at universities. Now, interdisciplinary collaboration fosters researchers to combine collective expertise and gain synergies. This may result in increased productivity, originality, and higher impact research. In academic institutions, most internal interdisciplinary collaborative research emerges from ad hoc groups based on personal relations. Without proper instruments to foster collaboration, organizational segmentation is likely to limit the potential of collaboration among actors, either internal or external to the institution, making it more difficult to foster inter- and multi-interdisciplinary ideas and initiatives. So, perceiving and analyzing collaborative research in academic institutions can be a way to develop academic policies for promoting further collaborative research. Networks of co-authorships are usually computed within the institution via standalone applications. Now, we are interested in development of tools that allow users and faculty boards to perceive the emergent social network structure of co-authorships and explore online the potential space of further collaboration in the institution. In order to do so, we implemented a tailored framework that allows examining the evolution and the structure of the co-authorship network revealed by scientific publication of authors of our university. The purpose of this work is to describe the framework design and its ability to generate and provide online different networks based on different algorithms. Main requirements include distribution, where users can access online the graph and analyze co-authorships from a website. Also persistence, where the graph is analyzed at a particular time. Communities are detected and stored, making it possible to access it in a responsive way, the evolution of the emergent network through time. And finally, modularity, where new algorithms for community detection can be added and capture alternative views of communities. Now, a co-authorship network can be modeled by an undirected graph in which nodes and edges represent authors and co-authorship relationships. Besides the number of shared scientific publications, there are other factors that are important to shape collaboration patterns among authors. For instance, if one article has 2 authors and another article has 10 authors, the authors in the former article should be considered more connected than those of the later article. We use the following formula to compute the weight of each edge, which expresses Newman attractiveness. Data for constructing the network originates from Scientia EUL. Scientia EUL is the institutional repository of scientific publications produced by the authors of our university. This information must be transformed into a network of co-authorships where community identification algorithms can be applied. The goal is providing users with online, easy access through a web browser. Now, with respect to the framework architecture, the framework contains 4 models as illustrated: a co-authorship graph generation, a community identification, a database, and a website. The construction of the co-authorship graph is a time-consuming process. Thus, once the graph is generated, it is persisted in the database. The modular nature of the solution allows future replacement of either model without compromising the use of the remaining models. For example, a new community identification algorithm can be added which uses the persisted graph in the database without any changes to the models responsible for generating the graph. The data are collected from ScienceUL through an application programming interface provided by ScienceUL and transformed into a graph with authors as vertices and co-authorships as edges between them. The application programming interface offers what are called endpoints to connect, gather information, or perform some functionality in the Internet. Such web services allow requesting systems to access and manipulate textual representations of web resources using an uniform, predefined set of stateless operations. To create the co-authorship network, we use the Node software. The framework is thus able to consult and compare communities calculated over time. Once the graph is generated, a simple network with no identified communities, it is persisted in the database and may then be accessed through the graphical interface in the website. Community identification algorithms can be applied, and their results also stored, persisted in the database and accessed through the website. The database has the structure as follows. Each co-author has two authors and at least one publication, represented by the publication entity. Whenever an instance of publication is created, its SIMAGO scientific categories are added in the SIMAGO categories property. A publication may be in several different co-authorings. Each of these entities has a set of properties that characterize it in the context of the co-authoring network. The detection of communities in graphs is a problem with vast literature, and it is normally known as a graph clustering problem. A community is a group of nodes with higher likelihood of connecting each other than to nodes from other communities. How to determine that a node belongs to a community and not to another is central in this problem. We use Newnham's concept of attractiveness in order to give us the likelihood of two nodes belonging to the same community. We implemented two communities detection algorithms, the Markov cluster algorithm known as MCL, and the attractiveness-based community detection known as ABCD. It should be stressed that other algorithms can be implemented, providing the online user with different ways to calculate communities. In what respect our results, we now summarize and analyze the scientific collaborations among the authors of our university. Our purpose was not fundamentally theoretical, but to describe, as a proof of concept, the kind of information a user can access and explore through the framework. We considered all the authors that have co-authored at least a scientific publication with another author from 1975 to 2017, which comprises approximately 42 years interval. It is worth to remark that only peer-reviewed scientific contributions were considered in this study. As you can see in the figure, the co-authorship network has around 600 nodes and almost 2,000 edges. To highlight multidisciplinary scientific collaborations, the shade of each node depends on the school that each author belongs. The school is basically the faculty. Among the approximately 600 nodes, there are different nodes representing authors belonging to respectively the School of Technology and Architecture, the School of Sociology and Public Policy, the School of Social Sciences, and the Business School. Now, despite having approximately 2,000 edges, the university co-authorship represents around 4,000 scientific publications. This is because some pairs of authors have co-authored more than one scientific publication. Now, the community detection. As previously mentioned, two algorithms for community detection were implemented, MCL and ABCD. Communities with less than 4 authors were not considered and were removed from this analysis. The MCL method, in the figure, identified 26 co-authorship communities in the network. Each different color represents each of the 26 co-authorship communities. The figure illustrates community networks for MCL algorithm. Only one of the communities, the one represented by yellow nodes, stands out on the network. In fact, there is a single community with 39 authors and approximately 121 co-authorships, whereas all the others have no more than 13 authors and 28 co-authorships. About 65% of the communities have less than 10 authors. Indeed, we saw that in both algorithms, 60% of the authors of the original network were discarded because they could not be put in a community with more than 4 authors. An explanation for this may be that the small number of authors in communities is due to the weak force of attractiveness of the co-authorships. Insofar as we have determined that only a community with 4 authors is valid, it was expectable that many authors will be purged. And now the conclusions. The scientific information provided online by Scientia UL and the framework described here were able to construct a co-authorship network and identify patterns of knowledge sharing in it. The distributed tool provides this information online and gathers statistically important information. There are also further challenges. These types of frameworks amount to further challenges in the domain of community detection. Community detection is a formal mathematical exercise. Once communities are automatically detected, we found a need to characterize the communities, that is, to provide the user with information in order to infer the identity or dynamics underlying the emergence of the community. In order to do so, some of the information provided may include the name, the school, the department, the research center of each community member, or the scientific areas of publications or the most frequent journals in the community. With this information, the user will be able to compare the results of the different algorithms, as well as more easily confront the resulting patterns with his own expectations about the communities in which he thinks is integrated in. So, in our paper, we describe the framework for easy and distributed access to this information, which we believe opens the door to further modular improvements of the solution over the web. And that's all. Thank you very much.
Hello, my name is Andrea Harchkova, and let me introduce you our research. It's called Examining the Linking Patterns and Link Building Strategies of Mainstream and Partisan Online News Media in Central Europe. I put here the faces of our research team so that you can at least see us like this. Let's define the mainstream and partisan online news media first, because these definitions differ from country to country. Partisan media are sometimes called also fake news media, but I don't use this term as mainstream media. For example, tabloids, they also contain sometimes fake news. The biggest difference between these two media are the attitude. In mainstream media, it's the pro-Western attitude, and in the partisan media, it's more pro-Russian attitude. Partisan media are defined against mainstream media. And another main difference is that mainstream media usually utilizes the real investigative work of journalists, and partisan media, the main sources of partisan media are social media statuses, etc. And this is how we came to the idea to study the sources in the form of hyperlinks to differentiate between these types of media. We would like to help to automatically determine the type of these media according to the different patterns of external hyperlinks that we believe that they are different between mainstream and partisan media. That's how we came to our research questions, where we ask if they are different, these linking patterns. What is the position of partisan news media in news media landscape in these countries, and who are the main actors? As a method, we chose hyperlink network analysis, that is a sister of social network analysis, that is a more common method in the field of fake news and rumors detection. Hyperlink network analysis is a little bit underutilized in this research. We found just two similar researches in South Korea and Hungary. Nevertheless, we think hyperlink network analysis is a suitable method because a website can be seen as a node that passes information from one actor to another. And it is also an indicator of relevance and credibility of a website by search engines. And hyperlink network analysis can be seen also as a part of webometrics research. Just webometrics is more focused on the analysis of hyperlinks in scientific resources. We utilized two tools for our research. Ahrefs is a crawler. It is said that it's the second most active crawler after Googlebot. Normally it is used for search engine marketing. In this tool we were mostly interested in, of course, the linked and linking domains, and the number of links from the target and to the target, and number of do-follow links. Do-follow links are the links that are followed by search engines. Those are not the links that are included in discussion forums or blogs. And do-follow links, they pass weight and help websites to rank better in organic search engine results. We analyzed 171 million of unique domains of hyperlinks with this tool. For visualization, we used a Gephi tool, and we assigned each website a unique ID when we defined it in nodes and in the edges. These websites are seen just in the form of these IDs, the source, like the linking domain, target, the linked domain, and we needed also to define the weight of the link, and the weight was the number of all links, and we assigned it also another attribute called do-follow, because we wanted to compare the weight of do-follow and all of the links. These are our selected websites. We covered Slovak and Czech, and also both partisan and mainstream news media that were the most popular in our countries. And here you can see the results of our research. We are quite surprised that mainstream news media create clusters of links to their own portals that they own. That means they don't link to another website in millions. And the exemption was just between two news media, but with deeper analysis we found out that it was just the redirects after one media bought the subdomain of the another one. The same pattern can be seen also in Czech mainstream media clusters, and the portals that they are linking, they are mostly business oriented or targeted to a mainstream lifestyle. The same individualism was seen when we analyzed the media of two states. There are no significant links between Slovak and Czech mainstream news media. The clusters are separated. The partisan scene is a little bit different. It is much more interlinked, and the partisan media, they link also to the mainstream media. Mainstream media almost never link to partisan media with two follow links, just from their forums or blogs where they are building links. Why they are doing it? We presume that it's just to gain some ostensible credibility in the media landscape. Czech partisan scene is also interlinked, like the Slovak one, but they are not linking to mainstream media, maybe because they have a stronger position, as we will see. Also, when analyzing Czech and Slovak partisan media, we can see they are heavily interlinked, also between two states. That doesn't happen in the mainstream media. And the heavy linking can point to their interdependence, or even maybe ownership, the same ownership, we don't know. The position of Slovak partisan news media currently is quite weak. We can see in the news media landscape just one alternative media. Unlike in Czech Republic, where almost 1/3 of the media landscape is dedicated to partisan media. To summarize the results, hyperlinks are reliable indicators of ownership or cooperation of the news media. We could see it on the clusters of mainstream media that were separated, and also on the links between mainstream and partisan media of the same ownership. It is not the indicator of citations, because we could see that mainstream media don't link very much outside their portals. The existence of these links only is not always the sign of the credibility of the news media, because we could see that partisan media linked also to the mainstream media. And linking patterns are different. Partisan portals are much more interlinked, also on the international level. That means that they transmit the content, they cooperate more, etc. Thank you for your attention. If you have any questions outside the Skype, you can write me to my email and I will be happy to answer you.
Good evening to everyone. My name is Miguel Valles, and in this opportunity I will expose an altmetric alternative for measuring the impact of university institutional repositories grade literature at the International Conference on Data and Information in Online Environments, Dione. As an introduction, nowadays Latin America and world universities are required a set of demands to fulfill the basic condition of educational quality that has forced them to guarantee better conditions for a comprehensive education of professionals graduating from their schools. To get a license, university must meet a set of standards to guarantee the education of their students. It involves installation and maintenance of an institutional repository to publish their grade literature. What are we looking for with this? The trend is to look for less heterogeneous, less unequal university scenarios toward the futures. But above all, it is thought that they assume the role that allows building a society with better living conditions for its population. A democracy and economy is strengthened as a result of increased science, education, and culture. Peru is not the exception, and in that sense, the new university law has had a special impact on process of professional education by demanding that university comply with 35 minimum standards. What do we have to do? Part of the requirements implies research results publication in open access through institutional repository to be used free of charge as a background for research or to strengthen the bibliographic review of a topic to be investigated. Once the research results are available, the design of strategies that allows to increase its visibility and impact factor remains, incorporating as part of repository functions the sharing of the results in social networks as a marketing strategy to achieve a greater audience than the academic environment itself. And what has Peru have been doing? In that sense, Peruvian government has been making efforts along with the universities to give licenses, demanding updated and accessible repository, so that the revision of their content serves to formulate a research project leading to academic and or professional degree. Therefore, Peruvian universities have been working to set up the infrastructure specification as well as on the identification of requirements and process training for the human resource responsible to guarantee that theses and every material published in their repository are available. Peruvian University uses this space to support this process. What to do for better? Measuring of repository performance indices and measurement of quality and quantity of bibliometric indices of scientific production used to take action to increase these indicators are complicated to monitor without a proper knowledge or techniques and tools available for this purpose. This also involves the design of a strategy that guarantees the use of the available material, visibility increase, and impact factor of publication using social network as a marketing and advertising strategy. The possibility for using social network to divulge the scientific production results, especially for repositories grade literature, has already been implemented in Peru and over the world. But what can I get and how to use the information generated? Thanks to configuring features for resources sharing on social network and incorporating free altmetrics function, we have increased our visits, reading, quotation, and impact and evident impact factor. This implies the need to measure, control, and improve these indices that cannot be tracked easily or efficiently by our repository software. A way to achieve this is through subscription to services of existing alternative metrics, for example, altmetrics, LumX, ScienceCard, Cyberse, Scopus, AP, and others. But what is the problem to do this? However, due to its high cost, complexity of initial setup work, and data loading, it has become a distant possibility for a university. For example, at my university, where we have less than 700 students and nearby 300 professors, we do not have enough budget, so we cannot subscribe to these services. Then, we want not to just integrate our use of social network as a marketing strategy to advertise our resource, but we want to use the information of relevant discussion of our content, analyze and compare the scope that dependencies have achieved within the organization, or know the audience demographic data that only paid subscription service provide. But how to access altmetric information without paid? Another way, without paid subscription, is using an application programming interface or API, which includes routines, data structures, object classes, variables, and response codes that subscription services provide. It is for free, it simplifies the process and allows access to altmetrics.com database for free to those who wish to understand the patterns of academic communication in the web. But the use of the API condition force attribution to source from which data has been mined, in this case from altmetric. So our objective was to create an alternative metric solution that integrates Google Analytics, GSpace, and altmetrics itself to monitor and increase the visibility of the institutional repository of the Universidad Nacional de San Martín here at the forest of Peru. For do this, our material and methods were the next. This works provides a dashboard-based monitoring tool that institutional repositories managers can use to monitor mention in social networks of their available resource. For this, we customize the institutional repository website, optimizing it and incorporating it altmetric function. Then, we mined the repository records that serve as income to perform requests to the altmetric API, resulting in a dataset from those resources that has been shared. Finally, with this data, we built the dashboard interface. For doing this, we use data and website of Universidad Nacional de San Martín Institutional Repository, where we incorporate the function to share the available resource. We deploy the dashboard based after we incorporate function, we deploy the dashboard-based monitoring tool in the following URL: altmetrics.unsm.edu.pe. The steps necessary to build, configure, and use the monitoring tools are parameterizable and standard. Thus, ensuring that any institutional that uses GSpace as its repository manager can use it. These are the steps that we do: customizing the institutional repository. We automated mining, transformation, and data upload procedures, and finally we built the monitoring tool and mining for altmetric data. Results. Now, as a result that we customize the institutional repository, our repositories manager have a set of tools to monitor analytical data where there are different segment metrics and analysis dimensions available. After the customization of our institutional repository website, our visits increased by an average of 65% compared to the previous period. This indicates that interface redesigns, social network inclusion, and site optimization suggested by Google Webmaster improved the repository visibility. As part of the result, we built an automated mining, transformation, and uploading of data procedures. We built a set of procedures that make all this process automatic. It is because to use our dashboard-based monitoring tool, the system automatically performs recuperation process weekly on Sundays at 0000 hours. However, there is also the possibility to perform the procedure on demand. Finally, as part of our results, we construct the altmetric data monitoring exploration tools that, on continuation, I'll expose. This is, first of all, this is our repository. We changed its interface. We put it more in a modern interface, and we optimizing it using Google Analytics, and we try to customize it that the colors are accord with our university. This, for example, is a resource that we have at the repository, and it has some function that people that find this resource interesting can share it on their social networks. For example, on Facebook, on Twitter, on Pinterest, and everyone they want. This is our Google Analytics, where we can look the increase of visits at our repository website. The orange line is before we make our customization, and the sky blue line are the increase of the visitors that we have after we customize the repository website. And finally, the most important or the most interesting thing that we have is here at the altmetrics.unsm.edu.pe, where we can find our monitoring tool that we built. As I told you, this monitoring tool was our objective, and here we can have information of where have been our resources shared without paid. We have a different way to show the information. For example, here we have that 77 theses have been shared from our repository. 73 are from the bachelor thesis, and here are from the different faculties that we have at the university. For example, at the system engineering faculty, we have 25 resources shared, and here are the details. For example, we can know that, for example, the ítem influencia de las redes sociales en el rendimiento académico de los alumnos was shared at least once en Facebook. The application de ITIL como herramienta para la gestión de servicios de tecnologías was shared at least twice at the social networks, specifically in this case by Twitter. And how can we know that? It's by the process of mining the data of our repository against the API And this is the data that we get. Here are more details from the alphametric tools. Yes. Conclusion. We will a dashboard-based monitoring tool where you may observe different indices of alternative metrics graphically. We customized and optimized institutional repository website incorporating altmetric and analytical function. The tool implementation of study case allowed us monitoring and control institutional repository altmetric indices of the Universidad Nacional de San Martín. An important aspect of this alternative is the low cost for implementation and customization compared to subscription to existing alternative metric services that has high cost and some complexity degree for customization that we cannot afford, thanks to features, functional and non-functional requirements implemented, as well as the standardized flow of process. This tool may be implemented at any university institutional repository and to certain altmetric measurement of its grade literature. Acknowledgements to Universidad Nacional de San Martín Tarapoto, Peru for financing the research project called Observatory of Social Networks and Alternative Metrics and their relationship with the different bibliometric indices of Institutional Repository of UNSMT, from which the results of this article arise. Thanks.
Dear all, now I would like to announce Best Paper Award for Dione 2020. The decision was made by the program chairs and general chair, who carefully evaluated all the papers submitted for the conference, and they decided that the Best Paper Award goes to a paper with the title A Blockchain Approach to Social Responsibility that was written by the team of authors of Venn, Capretz and Miriam. Congratulate you all for your excellent work and hope to see you at the next edition of Dione 2021, with the same location, Florianopolis, Brazil, 10 to 12 of February. Bye!
Hello, my name is Priscilla. I will present the work whose title is Identification of the Relationships between the Stages of the Data Lifecycle and the Principles of the Brazilian General Data Protection Act. The authors of this work are I, Priscila Fagundes, Gislaine Freund, and Professor Douglas de Macedo. We are from the graduate program in Information Science at the Federal University of Santa Catarina. I will open this presentation with the contextualization of the subjects, and afterwards I will present the results obtained from this study. In several countries around the world, laws regarding the protection of personal data have been in force for some time already. This map presents the world scenario and gives us an overview of the country's maturity in relation to the theme. In red, we have the countries that are very strong concerning the implementation of the law that deals with the protection of personal data. The countries presented in orange are also considered robust, but in a smaller proportion than those in red. In yellow are the ones considered moderate, in which includes Brazil. Here, the law was enacted in 2018 and the country is in the process of adequation to it. The Brazilian General Data Protection Law is based on the European Union law, and it sets out the principles that companies must take under consideration when adapting their process and technology. Thus, on the one hand, we have the law that regulates the treatment of personal data and its principles for adequacy. And on the other, we have the personal data that are spread and circulating in different departments of the companies and need to be treated properly to comply with the legislation. This is the scenario. The General Data Protection Law presents the following principles that must be observed when handling personal data: goal, adequacy, need, free access, data quality, transparency, safety, prevention, non-discrimination, and responsibility and accountability. In terms of data, we understand that its life cycle by segmenting the flow into phases according to its performance can be a support tool for this adaptation, and for that it's necessary to identify the existing relationships between them. Therefore, the objective of this work is to identify the existing relationships between the principles of the Brazilian General Data Protection Law at each stage of data cycle in order to guide companies through this adaptation activity. In addition to presenting the results of this analysis, this article aims to encourage new studies concerning the Brazilian GPDL and the data lifecycle, including research involving the proposal of models to be used in the process of adapting organizations to deal in some way with the storage of use of personal data to the new legislation. To do this analysis was important to understand each of the 10 principles of the General Data Protection Law. First, goal refers to legitimate, specific, explicit and informed purpose to the data subject for use. Adequacy, compatibility of the treatment with the goal informed to the holder. Necessity, limitation of treatment to the minimum necessary for the accomplishment of its goal. Free access, guarantee to holders of free and easy consultation on the form and duration of the treatment of their personal data. Data quality, guarantee to the owners of accuracy, clarity, relevance and updating of their data. Transparency, guarantee to the holders of clear, accurate and easily accessible information on the performance of the processing of their data. Safety, use of technical and administrative measures to protect personal data. Prevention, adoption of measures to prevent damage to personal data. Non-discrimination, impossibility of using the data for illicit or abusive discriminatory purpose. And accountability, demonstration by the agent of the adoption of effectivity measures capable of proving the observance and compliance with the rules on the protection of personal data. That it's not enough to be safe, it's necessary to prove that you are safe. Now, we proceed to a study of the data lifecycle model proposed by Santana. The data lifecycle comprises the steps in which the data act in a given process. Such steps correspond to the phases in which the data are related, creating a chain of dependence between them. Santana proposes four stages in the presented cycle, which are collection, storage, retrieval, and disposal. Collection aims to meet the information needs. It defines the data to be used, and a plan is carried out on how they will be obtained, filtered, and organized, identifying the structure, format, and description means which will be used. Storage. In this phase, activities related to actions aimed at persisting data in a digital medium are carried out. The focus in this step is to enable data reuse. About retrieval, and in this phase is related to the activities of consultation and data visualization. Its objective is to enable better access and use of them. And disposal, in this stage, the identification of data that is no longer needed and can be deleted occurs, focusing on providing the opportunity to eliminate unnecessary data. In his model, Santana also proposed 6 factors that permeate the phases of the cycle, being them: privacy, integration, quality, copyright, dissemination, and preservation. Privacy deals with the aspects that guarantee the privacy of people or institutions related to the data to be used. Integration refers to the identification and use of requirements that will provide the integration of the data with another data. Quality of the data is related to aspects to be considered, such as origin, collection mechanisms, physical and logical integrity, among others, to ensure that the data is reliable and useful. Copyright is related to the respect for the data author's rights. Dissemination is linked to the findability and access to data, and preservation of data is related to the preservation of useful data so that they can be used in the future. That said, we carried out the analysis, and for that we tried to answer the following question. What is the relationship between the principles of the Brazilian GPDL and the stages in the data lifecycle proposed by Santana? The following indicators were also used in the analysis. Very relevant for situations where the principle directly influences the stage of the data lifecycle, represented by the symbol a ball filed with black color. Relevant for situations where the principle indirectly influences the stage of the data lifecycle, represented by the symbol a ball without color. And unidentified for situations in which no relationships were detected, represented by acronym NI. With the analysis, it was identified that the goal principle has a very relevant relationship with the stages of collection and retrieval. When considering that the collection has the objective of supplying the informational need, identifying the goal of use the data is essential to meet this objective. It was also identified that the goal principle has a relevant relationship with the storage stage, considering that it's necessary to store the essential data for the identified goal. As for adequacy principle, a very relevant relationship was identified with all phases of the data lifecycle. When considering that this principle concerns the treatment of data appropriate to its goal, it was observed that all phases have a direct and important relationship with this principle. For the principle of necessity, a very relevant relationship was observed with the phases of collection and retrieval of the data lifecycle, as it's a principle that advocates the limitation of treatment to the minimum necessary to achieve its goals. It's observed that minimization in collection and retrieval can be adopted. A relevant relationship with the storage and disposal phases was also identified for this principle, considering that the minimum data retention can be adopted and the elimination must meet the necessary retention time and be consistent with the goal of using the data. As for the principle of free access, a very relevant relationship was identified with the phases of storage and retrieval. Since these phases include access control in the storage of data, but allowing access and retrieval of the contents to be available. For this principle, no relationship with the collection and disposal phases was identified. Regarding the data quality principle, very relevant relationships were identified with the phases of collection, storage, and retrieval. The similarity of the quality factor at work in all phases of the data lifecycle with the data quality principle favors the direct relationship identified in the analysis. For the transparency principle, a very relevant relationship was identified with all phases of the data lifecycle, as it's a principle whose objective is to provide holders with the guarantee of clear, accurate, and easily accessible information on the treatment of their data. It's directly associated with all phases, influencing the resources adopted in each one of them. When evaluating the safety principles, it was also possible to identify a very relevant relationship in all phases of the data lifecycle. It's observed that the protect personal data from unauthorized access and accidental or illegal situations. This principle must act from the collection of the data until its disposal. As with the principles of transparency and safety for the prevention principle, a very relevant relationship with all phases of the data lifecycle was also identified. It's considered that to prevent damage to personal data due to its treatment, it's necessary to adopt preventive measures at all stages. For the principle of non-discrimination, no relationship with any phase of data lifecycle was identified. It's understood that this principle is related to the definitions of the data use process and not to the data lifecycle itself. Regarding the principle of responsibility and accountability, there was a relationship with all phases of the data lifecycle because in order to demonstrate the adoption of effective measures capable of proving accordance and compliance with the rules of protection of personal data, this must be employed, practiced, and validated in all phases of the cycle. As final considerations, we concluded that personal data are present in several departments of an organization, and the relationships identified in this analysis can help the departments to map the adequacy actions for each principle of the law during each phase of the data performance. Thus, it's observed that the relationships presented in this study, the analysis and reflections they may provoke, support organizations in the task of adapting to the Brazilian GPDL guide by the performance of the data. In other words, the data lifecycle model proposed by Santana and the existing relationships of its stages with the principles of the Brazilian GPDL can be used as a support tool to systematize the process of adequation to the law by organizations. It's important to know that the relationships identified in this analysis are limited to indicating the points of attention for analysis and reflections for the adoption of techniques, technologies, process, or any technological apparatus or not to comply with the legislation, not being its objective to present what to do and how the principles of legislation can be met. Due to its general form of presentation, it can be used by organization of any nature that aim to adapt to the legislation or evaluate its compliance with it, identifying at each stage of the data lifecycle which principles need to be implemented, improved, or have already been contemplated or and are fully served. As a suggestion for future work, it's proposed that a study be carried out to identify the actions that can be taken to adapt the principles of the Brazilian GPDL at each stage of the data lifecycle, considering the relationships identified in this study. That's it. I finish my presentation here. There are our contacts, and thank you for the opportunity.
A method for collecting provenance data, a case study in a Brazilian hemotherapy center. Authors: Márcio José Sembai, Douglas Dilon Jerônimo de Macedo, and Moisés Lima Dutra. Organization of presentation topics. Introduction, literature review, information science, anemia in blood donors, scientific workflows, data provenance, provenance of knowledge, related works, proposal, case study, proposed method, step 1, step 2, step 3, step 4, results, conclusions, future perspectives, references. Introduction. What made me think about the subject of this research? It is estimated that in Brazil, 27 to 50% of the population have anemia, mainly low-income families. This article proposes a computational strategy method based on the Provenance Data Model, or ProvDM, to capture anemia indexes for analysis. The main objective of the method was to provide a broader analysis and improve the quality of blood donations. In this sense, in relation to the proposed method, the view of information science can contribute with its research methods, as it is associated with several interfaces of computer science. I am a doctoral student in information science that is closely linked to computer science. These interfaces, specifically in this article, are associated with scientific workflow structures to support the modeling of scientific experiments. Literature review. Information science. It is one of the areas most linked to information technology in the use of its methods for the development of research. Anemia in blood donors. Studies carried out by world-renowned health institutions indicate that anemia can be present in 80% of the world's population. Scientific workflows. Analysis by means of cycles carried out in scientific experiments. Data provenance. Description of how, when, where, and why was detected, and who was executed. Provenance of knowledge. Description of a source of part of the knowledge, including a description of the reasoning method used to generate it. Related works. In a doctoral thesis written in 2012 at the University of São Paulo, the author proposes a model for describing data provenance for knowledge extraction in hemotherapy information systems based on the Open Provenance Model, OPM, designed to manage provenance records. Other similar applications can be found in a paper entitled Laboratory and Clinical Genomics Data Sharing is Crucial to Improving Genetic Healthcare, the position statement of the American College of Medical Genetics and Genomics. Proposal. How was the method proposed? Based on the Data Provenance Model, or ProvDM. Origin data on anemia rates were extracted from reports provided by the Hemotherapy Center system from 2000 to 2018. The reports were transformed into a CSV file using Java Eclipse IDE and local PostgreSQL as an auxiliary database. The scientific workflow was generated with Taverna Workbench Core and the Jasper Reports library. It is important to note that an auxiliary database from the original database was created, facilitating the proposition of the method to guarantee reliable results for the generation of new knowledge. In this sense, it was possible to store data from provenance related to anemia indexes in the auxiliary database without changing the structure of the original database. Case study. Proposed method. How was the method based on the ProvDM model proposed? The ProvDM is divided into 7 components that can be seen in Figure 1. Thus, they understand the 19-year data extraction of anemia rates found at the Hemotherapy Center. Figure 1, proposed method. The method proposed here is presented in 4 steps. In the next slides, each step will be presented. Case study, method, step 1. Step 1, entities. Entities. Data provided by the Hemotherapy Center data source are collected and selected so that they can undergo the second step of this transformation process. Case study, method, step 2. Step 2, activities, agents, and derivations. Activities. Set of data collected containing dates, times, consumption, processes, transformation, modification, relocation, and use of the original data. Agents. Candidate for blood donors and health specialists. Derivations. Data transformation after applying the proposed method. Here, the scientific workflow presented aims to extract data from attributes considered reliable for analysis, and after that, they are transformed into a CSV file to create an auxiliary database to generate tables and graphs. Case study, method, step 3. Step 3, alternative and collections. Alternative, statement of anemia rates of blood donation candidates deemed unsuitable. Collections, collection of data from anemic candidates to be inserted into the local source data repository. This step stores the source data in a local repository. Here, it is also possible to apply the concepts of knowledge origin in order to contribute to data analysis. Case study, method, step 4. Step 4, notes. Notes represents the list of important points in relation to anemia rates. This last step creates an interaction between refined data and expert reports. Results. What results did I find? The body of each report provided by the Hemotherapy Center contained a series of attributes from which only the data with the potential to generate the expected results were selected, which can be seen in Figure 2. Figure 2, auxiliary database with selected attributes. Results. Table 1 also shows that from 2001 to 2009, there was no screening, but anemia rates continued to be predominantly female. In 2018, the largest number of tests was observed, for some specific reason not identified in relation to blood donations that year. Table 1, number of donors. Fit, unfit, anemic, unfit, percentage of anemic, unfit, and screening. Table 1 shows the results after blood tests and a filter for at least 80 reasons for refusals. $197,551 blood donation candidates, men and women. Men, 89,657 considered fit, and 25,156 considered unfit for blood donations. In 1,011 candidates, anemia rates were observed, totaling 4.02% of unsuitable candidates for blood donation. Women, 57,633 considered fit, and 25,105 unsuitable for blood donations. In 4,039 candidates, anemia rates were observed, totaling 16.09% of donors unable to donate blood. Results. In 2001, the highest rates of anemia in men and women were found. Compared to 2018, when there was the highest screening rate, the anemia rate was well below the 2001 average. Table 1. Number of donors. Fit, unfit, anemic, unfit, percentage of anemic, unfit, and screening. These comparisons help to establish estimates and thresholds for further studies in the field of hemotherapy from the point of view of the data source, which can contribute to the prevention of anemia rates at the Hemotherapy Center. Results. Figure 3 shows a graph of refusals due to anemia, men and women. Anemia rates in men are lower than in women due to the interval between blood donations. Women develop anemia earlier than men for reasons associated with pregnancy and monthly female blood loss. Figure 3, refusals due to anemia, male and female unfit. For men, the chances of developing anemia are associated with some type of bleeding or regular blood donation. According to the literature, recommendations for reducing anemia rates in men and women are related to iron supplementation after blood donation and an increased waiting time between donations. Conclusions. The female sex is prone to develop more frequent rates of anemia. The method proposed here can contribute to the advancement of research in Brazilian hemotherapy centers. The main contributions of the proposed method were: A. To improve the analysis of anemia rates that make blood donation unfeasible. B. Increase in the quality of blood donations. And C. Possibilities for auditing hemotherapy systems. Future perspectives. Data collection to be carried out in a cloud computing structure. Use the data collected here to avoid anemia rates that result in refusals of blood donations. Improve the method with cross-data from other hemotherapy centers. For these future perspectives, Brazil must improve its data storage infrastructure and computational tools applied to Brazilian hemotherapy centers. Computer science combined with the information science point of view can contribute to the development of new hemotherapy information systems capable of preventing anemia in blood donations at hemotherapy centers in Brazil. References. These were the references used in this paper. And this was a method for collecting provenance data, a case study in a Brazilian hemotherapy center. Authors: Márcio José Sembai, Douglas Dilon Jerônimo de Macedo, and Moisés Lima Dutra. Thank you very much.
Hello everyone, my name is Guilherme, and this is a recorded presentation for the International Conference on Data and Information in Online Environments of 2020. Our paper is entitled Personal Data Protection and its Reflexes on the Data Broker Industry. We will talk about internet privacy, data brokerage business, the laws that have been enacted worldwide to address personal data privacy, and how they affect data commodification. Web services, big data, cloud computing, cloudlets, the Internet of Things, and data brokers. Those are all buzzwords associated with modern tech trends, except for the last one. Data brokers are as old as the net itself. After all, since information started being published online, there has always been a need for aggregators, as there always have been those who are interested in their products. Compilations from sparse sources generating specific dossiers about something or someone. On one side, ordinarily control-avid governments armed with the national security argument. On the other, the refinement of targeted marketing, progressively individualized, declared, and inferred tastes. In the middle lies the target, the user, whose every search, every click, every like, every post are all cataloged, reunited, processed, and not rarely or maybe very frequently sold to third parties. New technology makes it possible to measure and monitor more and more of our electronic communication and information activities. Business and government see this potential as a major instrument to increase profit and control. So, what are data brokers? They are companies that collect information, including personal information about consumers, from a wide variety of sources for the purpose of reselling such information to their customers for various purposes, including verifying an individual's identity, differentiating records, marketing products, and preventing financial fraud. Basically, what data brokers do is explore data, turning or treating it as a commodity. Commodification is the process of making things exchangeable on markets by framing them as if they were exchangeable. The abundant volume of information that people generate every second doesn't take long to have its potential recognized. Becoming beyond a commodity is a whole new specialized business. Such phenomenon is helping a shift in corporate attention from production-oriented to marketing-oriented strategies, allowing companies to tap into and encourage purchase behavior. This slide shows an ordinary flow of information to and from a data broker. Examples of where they collect data from are social networks, web crawling, internet browsing, purchasing history, and private databases, but also public records, such as data from open government, census and property records, and so on. From that collected sparse mass, data brokers apply several refinement processing steps, from formatting and filtering, to the point where information can be obtained using math and machine learning. Individuals can then be clustered together when sharing similar attributes, generating statistical knowledge on groups or rich dossiers on someone specific. Clients of such products include insurance and financial institutions, seeking risk mitigation and fraud detection, retailers, who look for consumption profiles, and law enforcement interested in strengthening their investigation and predictions. Although a growing market and virtually multi-billionaire, the dissemination of the data broker business model cannot occur without questioning. Debates orbit around recurrent subjects, among which three are commonplace: transparency for when data is captured, loss of control over one's anonymity, and the sharing of the profits. On transparency and control, in the early 2000s, the first generation of data security laws started with a pioneer Californian bill. That law mandates that any breach of security on personal data to be disclosed, which ultimately helped bring the data business to the spotlight. This slide shows the annual spending on cybersecurity in the United States from 2010 to 2017. It is interesting to notice that during that short period, spending has more than doubled from nearly $30 to $60 billion per year. On the other hand, although spending twice as much, the number of breach events have been pretty much constant. Companies have had to invest more and more, only to keep the harm at a similar pace. This one is also interesting. We've seen from the previous graph that the number of yearly breach events remained still over the earlier decade. However, while summing up the number of compromised records, one can notice that the figures are growing exponentially. One plausible explanation is that databases are getting larger, possibly with the dissemination and usage of big data techniques, but one breach event will affect much more people. Here, we display the typology of the data breaches in that period. While at first one would think that breaches would mostly be accredited to hacking and malware, there are also several important causes. The loss of data media, either portable or stationary, insider leakage, and unintended disclosure all account for a great proportion of the breaches. One of the main problems of the disclosure of personal data and that causes huge losses is identity fraud. Identity fraud can be described as the misuse of personal or financial identifiers for personal gain or to facilitate other criminal activity. Examples of such are online shopping scams, the usage of stolen cards, or controlling and spending over someone else's accounts. Now that we have described how data brokers operate and profit from personal data, and how their business model was uncovered by laws that mandate notification of data breach events, we will present the next generation of laws created upon data privacy debates. The European General Data Protection Regulation, recently effective, has affected hundreds of companies and led other countries to create similar laws, such as Brazil. In South America, Uruguay and Argentina have had their own regulation for years. Their laws, albeit older, were considered already adequate by the European Commission for protecting personal data. Some of the key points addressed by the European regulation are now highlighted in a before and after fashion. Regarding the language used on privacy policies, before, the terms were usually lengthy and complicated, while after, they are expected to be short, clear, and straightforward. On user consent, before it was assumed upon silence from the user, or requested in a somehow hidden way, while after, the consent needs to be affirmative. Silence is no consent. On the issue of transparency, users will need to be informed when their data is transferred outside the European Union. Also, data can only be collected for a previously informed and well-defined purpose. Before, users were unaware of decisions made by algorithms. Now, automated decisions need also to be informed. On stronger rights, data breaches will need to be immediately disclosed. The regulation also grants the user the right to move his data, for instance, to another media platform. Obtaining a copy of the data a business has on a user could also be facilitated. At last, users have the right to be forgotten, which means a right to have their data deleted from a business. Finally, on stronger enforcement, to ensure the regulation is being properly followed, protection authorities were created, which have harmonized powers and are able to impose fines. New Brazilian law enlists 10 principles that are similar to those of the European regulation. First one is purpose. Data must be handled with legitimate, specific, and explicit purposes. The next one is suitability. Data must be handled in a way that is compatible with the goals informed to the user. Necessity. Data handling must be restricted to the minimum necessary to fulfill the purpose it was acquired for. Free access. Users' access must be provided in a free and facilitated way. Data quality. Users must be assured about the correctness, clearness, relevance, and currentness of their data. Transparency. Users must be given clear, precise, and easily accessible information about their data usage and handlers. Security. Establishment of administrative and technical rules to protect personal data from unauthorized access. Prevention. The following of means to prevent damage due to data mishandling. Non-discrimination. Processed data must not be used for illicit or abusive means. And finally, accountability. The data handler must demonstrate actions to prove such steps are being followed and enforced. Upon the enactment and enforcement of new rigid regulations for dealing with personal data, the following outcomes have been speculated. Are we going to see a downfall, or maybe even an extinction, the age where personal information was treated as a commodity? Or are we going to experience a shift, a new paradigm where such businesses still thrive, but now adapted to the transparency model? One thing appears to be certain. According to all new laws, now there must be much more respect to the users and their individual authority on controlling who they are and what data they generate. The answer, some suggest, is a new approach to the data-driven industry, which should focus the collaborative point of view in order to survive. Such idea elevates the user so that he now has, if not a leading, yet a supporting role on businesses dealing with his data. From that standpoint, some proposals have been published. One of them suggests that data should be placed on a platform created as a market, with negotiable policies that include purpose, type of data, retention period, and price. Another idea points to the establishment of entities working as data vaults, where users would maintain control over what is shared, reviewing and filtering the data before someone else has access to it. The challenges for pursuing a collaborative perspective while dealing with users, their data, and user data consumers have been narrowed to these potential issues. First, going through and finishing the ongoing adjustment cycle to the recent regulations. Next, enforcing that all the rules are being properly followed in the new business model. Then, quantifying the monetary value of personal data will also be an issue in a transparent approach. And finally, effectively deploying collaborative platforms and products will be the ultimate challenge, as nowadays no such solution has been successfully acknowledged. Thank you for listening. If you have any comments or questions, feel free to send an email. Cheers!
Hello everyone, my name is Leonardo Marcelino and I'm going to present to you the paper entitled Intellectual Authorities and Hubs of Green Chemistry, written by Adilson Luiz Pinto, Carlos Alberto Marques, and myself. We are all teachers at Universidade Federal de Santa Catarina in Florianópolis, Brazil. First of all, I'd like to set the context of that research in my PhD in Science Education, whose dissertation was on types of rationality in green chemistry and their relationship with teaching. In order to discuss those rationalities, we needed to select a set of papers that are representative of the green chemistry field. We found that co-citation analysis would be a suitable tool for that. Green chemistry is a new way of doing chemistry, focusing on designing products and processes that are preventive of pollution and prevent risks to the environment and to health. It is a new philosophy in chemistry aiming at addressing the environmental crisis, situating its practice around 12 principles of design. The co-citation analysis was made by SitSpace software. We chose this program because it's based on Kuhn's theory on the development of science, enabling the investigation of the dynamics of a knowledge domain. So SitSpace analyzes this domain in terms of specialties, which are defined as a relationship between a time-variant network of co-cited papers, which is called intellectual base, and the papers that co-cite these nodes are in the research front. SitSpace software offers information on the research front and the intellectual base, and uses networks as a representation of the knowledge domain. Although the co-citation network is suitable for representing the structure of the field, we needed to filter relevant papers and authors from the network. So we did it by concepts of hubs and authorities. So John Kleinberg proposed an algorithm to analyze the importance of a node in providing content of relevance, which is called authorities, and the importance of nodes in selecting, grouping, and disseminating information, which is called hubs. This algorithm was based on mutual recursion. What means is that important hubs connect to important authorities. The problem is that SitSpace has a network in two levels. The network itself is made up by papers in the intellectual basis, but we also have information on the research front, which is not directly included in the network. That is why we had to develop a working definition for hubs and authorities, so authors in research front may act as hubs, having high degree of connection, grouping the intellectual base around a theme, and disseminating information throughout the community. Authors in intellectual base may act as authorities, linking many hubs. The authorities provides the knowledge to the hubs to disseminate. The indicators we used to select the hubs were the coverage value, that is, how many references an author co-cites, the global citation score, which is the amount of citations received from the scientific community as a whole, indicating the recognition by the whole scientific community. And also we use coverage, which indicates how many references an author co-cites. And this is an indication of how well these hubs group the research around a theme. The indicators for authorities are based on citation frequency, saying how many times an author appears in the reference in the dataset. The citation burstness, which is a sudden increase in the citation score and indicates a degree of innovation related to that paper and to that author. And the between us centrality, which is the ability to transit among specialties. So we sought in the Web of Science database for articles, reviews, book chapters, and proceeding papers published from 1990 to 2017. Then we had two sources of data, topic search and specialized journal. In the first one, we sought for the term green chemistry in the abstract, the titles, and the keywords of the papers. But we realized we didn't retrieve a lot of papers in Green Chemistry Journal, which is the biggest journal in the field. And we realized that Green Chemistry Journal does not use keywords, or it does not use the term green chemistry in titles or abstracts, because the journal itself is directed to the field. So we decided to consider all the papers published in Green Chemistry Journal and Green Chemistry Letters and Reviews, the two biggest specialized journal of the field. Overall, we retrieved 14,000 documents in May 2018. So CITSpace creates one network for each time slice and then merge them all together, creating a historical depiction of the field. We analyzed the changes in modularity Q and the mean silhouette when we use the different values of time slices and top n. The best values were obtained in the period of 3 years and for the top 100 papers. So modularity Q is how well a network can be divided in cluster, and we obtained the value of 0.83. The silhouette is a measure of how cohesive are the nodes inside the cluster, and the mean silhouette we obtained was 0.44. The lookback year is another parameter in the CITSpace software, which states how old the references can be in order to be included in the network. So we use -1, which says that there is no limit to the age of the references. Other parameters followed default settings in the program. After we created the network, we performed a clustering analysis, generating 16 clusters in the largest connected component. Other clusters were created outside this major section of the network, but they were not analyzed. After clustering, we attributed names to those clusters manually, analyzing the titles and abstracts of the research front and considering the terms, concepts, and instruments and tools that are repeated along those papers. We did not use the automatic naming of clusters in CITSpace because it was not very accurate. The validation of the results relied on internal validation through the values of silhouette and modularity Q, and by external validation, considering peer recognition, that is, a comparison with previous qualitative descriptions of the field. So here we can see the network in general. This large node in the middle of the network is a very important authority, as we will see later. The size of the node in this network determines how many times it was seated or co-seated in the network. So we can see that this node here was written by Anastas, which is the founder of the green chemistry field. So here's how SitSpace presents the data. So in the intellectual base, each node represents a paper, and each paper has a cluster, a frequency, a centrality, a burstiness, a sigma, and a half-life value attributed to it. In the research front, each paper has a value of coverage, a global citation score, and a local citation score attributed to it. So here we have the results. There are 16 clusters. So all these clusters have the value of silhouette higher than 0.76, indicating a good cohesion of these clusters. And we can see that the lowest value is in cluster 0, the biggest cluster, indicating that even the biggest cluster has a good value of silhouette, has a good cohesion inside. The 16 clusters were further categorized into 6 big specialties. The big specialty A, solvents, has 4 clusters. Big specialty B, ionic liquids, has more 4. The big specialty C, biomass, has 3 clusters. D, catalysis, has 3 more. And we have this big cluster, number 1, characterization of green chemistry. And this smaller one, the CO2, as a substrate. So here we have a representation of the big specialties and how they are connected together. So we can see that the cluster 1, which talks about characterizing green chemistry, is in the center of the network, indicating it acts as a core for this whole field, establishing its characteristics and its attributes. We can see that the big specialty B, ionic liquids, is very cohesive and has all its members related to each other and a lot of connections between them. We can also see that the big specialty C, biomass, is also very related to each other. The clusters inside are very related. The other 3 big specialties, which is solvents, catalysis, and CO2 as substrates, they are further dispersed into the network, and they are not very cohesively connected. This indicates that those big specialties, they have very scattered themes and tools and methodologies. And although their concepts and their themes are very close to each other, their patterns of co-citations is not very related. So after doing this, we had to analyze the hubs and authorities in that network, and we did it by separating all authors and co-authors in the research front and the main authors in the intellectual base. So in the research front, we attributed the value of coverage, which was made by summing all papers co-cited by an author in a clusters and dividing this value by the total of papers in the intellectual base of that cluster. The global citation score was made by the sum of all the citations received by different papers published by an author in the research front. In the intellectual base, we selected the authorities by making a simple sum of the number of papers published by that author, summing the citation frequency, or how many times that author appeared in the intellectual base, we made a sum of the between centrality of the different papers and the citation burstness of all the papers by an author. So this is how our results were presented. So we have here, as an example, the tables for the specialty A, solvent. So we can see the main authors in the research front of these specialties. We can see the values of coverage they have in the big specialty A, the values of coverage in the whole network, the value of citations inside the big specialty A, and the value of citations in the whole network, as well as the number of big specialties that those authors participate. We can see by this table that two authors are very relevant, which is Cadierno and Francos. In the intellectual base, we have these authors, and here we have the number of papers they publish in the big specialty and in the network in general. We have also the values of citation burst, of between centrality, and citation frequency. Again, we see that two authors are very relevant as authorities, considering its number of papers published, their citation burstness, and the value of citation frequency. So here we have all the hubs and authorities that were retrieved in this research. I would like to point out that the big specialty E, green chemistry characterization, is a very important one because it talks about the nature of this field. And we can see that Paul Anastas, Roger Sheldon, and James Clark are the hubs of this big specialty, and they are very acknowledged and recognizable authors, so it contributes or it corroborates findings. And as authorities, we have Roger Sheldon, James Clark, David Constable, Alan Curzons, and Barry Trost. They are also very acknowledged and recognized researchers in the field. It's interesting that we find Anastas as a hub of the field. As he is the father of green chemistry, we suppose that he would be its authority. But the fact is that Anastas is working in disseminating and divulgating green chemistry around the world, so his articles and his papers are directed toward analyzing the green chemistry, analyzing what has been done, and promoting its practices. So he is a big hub, so he is a very good example of a hub in green chemistry. Our results were validated by the values of modularity Q, which was 0.8302, as we stated before, and the value of silhouette, which was higher than 0.76 in all the clusters we analyzed. The external validation showed that the themes or the content of the specialties are mentioned in editorials and other reviews in the field, indicating that those qualitative analyses, they find the same results as we did. But the difference is that our research shows the relative importance of the specialty. So they show how big and how small they are and how they are connected, which those qualitative analyses did not do. So as final remarks, we found 14 authors acting like intellectual hubs, and they group and disseminate knowledge. 21 authors act like intellectual authorities, they sustain the knowledge in the field. We found that co-citation analysis is going to be fruitful for analyzing hubs and authorities and creating a panorama for the field. And this research contributes especially to a better understanding of the structure of the green chemistry field and also to assist researchers in looking for relevant information. in the literature of the domain. Previous analysis of the field departs from the 12 principles. So they have a priori categories, and this research considers only the patterns in consultation. One difficulty we found in this research was the lack of standards on the database. Some journals do not have author keywords, as the Green Chemistry Journal, the biggest in the field, and also the dataset changed after we did the research. So the keywords plus algorithm in the Web of Science changed, and we could not retrieve the same numbers or the same papers we retrieved in May 2018. So here we have some references we used in this research. We can have access to all the references in the paper. So here you have our contact in case you have any questions or you have any suggestions. And for your attention, thank you.
Librarianship in the Age of Data Science, Data Librarianship Venn Diagram, Alexandre Semeler and Adilson Luiz Pinto. Propose. Currently, data are stored in always-on condition and can be globally accessed at any point by any user. So, the intention of this study is to apply a Venn diagram to describe a background for data librarianship as a practice field in relation to other fields as information science, e-science, and data science. Data librarianship Venn diagram. The data librarianship Venn diagram describes the union and the intersection between information science, e-science, and data science. With this diagram, it's possible to conceptualize a background of data librarianship. Using three theoretical sets, it is possible to visualize the nucleus of the data librarianship as a field. First set is information science. Second set is e-science. Third set is data science. Core of Venn diagram, data librarianship. The origins of the data librarianships were in the emergence of research data settings stemming from the utilization of quantitative research methods and the social science, and especially public data held by public institutions like electoral electronic census data and economic data for business. Data librarianship has its origins in social science, in particular the creation of data services and data archives in the United Kingdom, data archiving services, and the United States and Canada, data library service, is a key factor for the emergence of data librarianship. The focus of data librarianships nowadays is on the creation of the new library services. Data librarians are concerned with the proposition of services for data management and curation in academic libraries and other research organizations. Data librarianship has been shaped by cultural norms to do with research funding, institutional expectations, and academic practice. Basic understands of the what constitutes of the data librarianship. It is an evolving blend traditional librarian skills, such as advising on research discovery on the one hand and providing background on the specific issues of data formats or digital obsolescence on the other on some occasion it may require the application of the full specialist and knowledge about collection or undertaking analysis. At other times, it may require providing advice on copyright, management data as part of the research process, or selecting the most appropriate data analysis tool. A data librarian. A data librarian who works all or part of the time with data. Librarians will be working in some parts of institutional library, be it academic, school, public, business, or other special library. There are librarians working with data outside of libraries, for example, creating a corporate taxonomy or working with researchers outside of a library setting. And it is still likely that there will be more jobs outside of libraries as employers realize how a well-trained librarian can help to find, organize, and analyze information. Data librarians in current times need technical skills to extract, analyze, and present data. A data librarian needs to combine skills and knowledge required for data management, data creation, and competence to support for research data management. For set 1, information science. The first set on the data librarianship Venn diagram is information science. Information science is a field of study where interdisciplinary ideas circulate. It is considered all forms of interaction between people and information. Information science is a multidisciplinary field of study, involving several forms of knowledge, given a coherence by focus on the central concept of human record information. The concept of information and technology are fundamental to the comprehension of information science in digital context. Information concept be applied in conjunction with a documentation field such as librarianship, among other aspects applying to technological information systems. Technology driving the pervasive behavior of digital information has changed our existence that has been increasingly mediated by technology. Technology presents itself as a multifaceted reality. Not only has objects and set objects, but also has system, process, modus operandi, and mentality. The most common way to think technology is to regard it as something concrete. In other words, technology manifests itself primarily as objects, as material artifacts made by man, whose function depends on a specific materiality. Under this bias, it is necessary to reiterate to technical devices are in part user-dependent and using and handling them require special skills and training of technology. Set 2 is science. The investigation methods based on use of hardware infrastructure and scientific software have allowed the emergence of data-intensive research. Data-intensive research is related with extensive use of data carried out in natural science, social science, and the humanity, also called Research 2.0 or e-science. The e-science is the data-intensive research phenomenon. It is responsible for the generation and the use of data in the large quantities. In the big data era, data information and technology are pervasive. Data-intensive research or e-science is a contemporary data information phenomenon. Scientists believe that data-intensive research will optimum result the intensive use of technological instrument and device. The theoretical understanding of these studies is based on appreciating the fact that nature of scientific things depends on the materiality of the technical device. Therefore, scientific instruments are the key to contemporary scientific practices. These conclusions making science less about knowledge than about a practice that's involving using machines and technical devices. Third set, data science. Data science is a field of knowledge that merges techniques of computer science and statistics. It can be considered as a new area of study for librarians seeking to engage with issues relating to data analysis. It is a field of knowledge that demands specific expertise, usually relating to statistics and programming languages. The objective of data science is to reveal the characteristics and or structures of natural, human, and social phenomena using of data. It can be considered as a new area study for librarians seeking to engage in data management and data analysis. In the search for scientific stats for data science, describe the different objectives that make it scientific discipline. The authors suggest that data science is the study of the scientific data, study of business data, interaction of statistics, computational technology, and artificial intelligence, and solution of scientific and or business issues relating to the extraction of knowledge of data. Finally, final remarks. For the further studies, it suggests that data librarian investigates themes related to research to data usage in diverse contexts such as big data, Internet of Things, artificial intelligence, informational patterns, and scientific communication. It shall be interesting to accomplish study about the possible analysis of the metadata of these fields and the content storage research data repositories. Thus, in conclusion, this paper recommends that data librarians should work with research data repositories, supporting researchers for the first steps of scientific investigation, assigned with the documentation process, and provide the assurance that this research data will be preserved, usable, and reusable in long term. A data librarian must be using the fundamental value, ethical principles, skills, and professional knowledge of librarianship to work with research data, especially at digital repositories. Thank you.